No.
Finish now.
One more set. Just one and a half.
From your door, you finish now?
Yeah. Yes.
All right.
Yes.
All right, so I need a scribe. Who's going to write? Kezia, come. Let's talk about the different errors. Alright, so Orantos, tell me one of the errors you notice when you notice it in decimals. What's one of the things you notice? The wrong things.
In decimals, I noticed children or in what I've seen is the positioning or the multiplication, they always put like decimal place in the incorrect position. And it's
Very good, that's a big problem. Place value.
Yeah, place value.
For multiplication. And that could be for all decimals. Everything about decimals. So you don't even put for adding, subtracting, multiplying, division, rounding. A big problem there for decimal is understanding the place value. Place value. Anything else? So we're going to discuss that in depth a bit more.
No, it was mainly place value. I think that was the issue.
All right.
You could say order of operation for decimals, but I put that somewhere else.
I didn't hear that.
I think I think you could put order of operations like.
I would put that also. Depending on what they're doing, order of operation.
Yeah, depending on what they're doing, like multiplication or whatever, or even division.
Crystal.
Yeah. Okay, Ms. Crystal, she put changing converting decimals to fractions. She had to leave a minute.
She's coming right back. She had to leave those margins. Just stepped up.
Changing decimals to fractions.
So it's converting conversion.
Converting.
Yeah, I'm ready.
Yeah.
Hello, good morning.
Good morning, Adrian.
Adrian.
Morning, miss. Morning, class.
Morning.
Okay, so Adrian, do you have anything to add? You just came in?
Yes, miss.
Alright, so we're looking at decimals. We're looking at all the likely misconceptions or likely errors that students will make while solving any problem involving decimals.
Okay.
Can you come up with any? So far we have place value, order of operation, and conversion. Do you have anything to add?
No, miss.
Alright, so Jomo.
I think more rounding out errors like rounding out something I do that's on place.
Rounding.
Yeah.
You just kind of found a place for it, but put it right there. Want anything now, Kezia? Alright, let's look at these errors a little bit more closely. Let's look at decimal. Place value. What are some of the place value issues we have with decimal? So this is the thing. So they are multiplying 2.3 times 1.4. And what do they do? How do they do this? 3 fours 12, 2 fours 8, and 1 what?
9.
And then they put a 0, 1 3 3, 1 1 1. 2, this is what 12.
That should be 2. I want to get 2. Push the camera up a little bit, please.
And they put a point right there.
I see 4. To the right.
Can we see the board, please?
Yeah, just move it a little bit to the left. Yes. Just shift it to the left, left.
Right here.
That's
You're
right.
right.
That's,
You're right.
that's
You're
right.
You're right.
All left. All left. Over, over, over. Yeah, right there. Perfect.
Okay, that's fine. Now come back.
That's fine.
Excuse me.
Yeah, that's exactly what we,
Yeah.
and it should
And they
be,
put one behind that.
yeah, they put, it should be 3 point. That's exactly what we, yeah.
And give me a second. So I want you to look at that and tell me what you think the main problem is. Place value. But why should the student be able to look at that and say something is wrong?
Yes,
Well, they don't have to say something's wrong, because if they don't understand placement, then they'll say, is there only one decimal behind the 3? Is there only one number behind the decimal? So they're gonna put one number behind the decimal, but that's not logic.
that's the logic.
They haven't taken into account what the decimal is, or what the significance of the decimal.
It's multiplication. 12.
Now look at this. Let's look at this and let's look at this. This, you know, we need to train students to be able to look at the answer and know that something is wrong with the answer. How could you look at the answer and know that something is wrong with the answer?
So then multiply 2 times 1. I can multiply 3 times 2.
Even multiply, even round that to 4, that is 4 times 2. 4 times 2 is what?
8. So there's no way
So there's no way. So even to be able to look at the answer, students should be able to look at this answer here and see that something is wrong with the answer. So we have to get them start thinking like that. Are we clear, everybody?
Yeah.
Yes, miss.
Good. So because they're accustomed to when they're adding. So this is coming from the additional concept, without even thinking. When they're adding, they need to go down in a line, because that's what the teacher will tell them. The decimal point needs to be at a decimal point. So when they're multiplying, they still do the same thing. But it's a lack of understanding. They're not thinking. So we have to start training them how to stop, look at your answer. So this is something we need to do in the class. Can you look at the answer and tell me if this answer is possible? Why is it possible? Why is it not possible? Are we clear?
Yes.
Another arrow that students normally make in the rounding. So that's a one place value. Even with division.
Miss.
Yeah.
Miss,
Yes, I'm hearing you.
could we add estimation then to the table?
Estimation.
Yeah.
It's there. It's there.
It's there?
Yes, it's rounding, but rounding is the same. Estimation is big heading, and rounding is a subtopic of estimation.
Okay.
You agree with me, Adrian?
Yes, miss.
Good. So even when they're dividing, if they have 3.1 divided by, let me just give you 16.1 divided by 4.2. Even just being able to look at that, they should have an idea. We don't even start working. So when they come with some answers, they should know that we're going to look at the methodology for teaching these things also. But that's on the focus right now. we're looking at, should students be able to identify that something is wrong with their solution? We have to teach them to look at the answer and know that this can't be the answer. Place value. Another, this is a big one. So they wrote something need to, so they have, give me a number, please. The decimal number. 0.783. And it's rolled into what? 2 DP, the 2 decimal places.
78.3.
And what? Look at this now. What is this number? Because so this, it comes back to the word not understanding place value. So this is in the 10th place, this is in the 100th place, and this is in the what? 1000th place. When you look at this number, is it greater than 1 or less than 1? It is what? Less than 1. So look, so these are the questions that we have to ask. Is this number greater than 1 or is it less than 1? If we're rounding, what are we doing? The value must be very close to the original thing. So when they do this, and they move the decimal point, and they give you 78.3, that's what they give you now.
What?
They should not.
Yes! You've never seen that, Adrian?
Yes, miss.
That was a record.
That was me, I'm sorry. I'm sorry.
You've never seen that?
Yeah, I have.
It's not very common. Even the college students have seen this one. This is a very, 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 very common one. Want to tell you
Miss.
to round off? Yes. Yes, Adrian?
Yeah, I'm saying this is very common, especially when they are doing significant figures.
Especially, and significant figure is another way of what? It's estimated. Look here, it's the same number. I'm just writing it another way. It's the same number, I know. So standard form significant figure is the same number, but I'm not giving an exact value. So even standard form is the same number. I'm writing it another way. So when I work out that what I came to, the answer to have, I should get by the original thing. It should be the same value. So the place value concept is, we're looking at this for you to know that you have to revisit place value. It's important. You have to go and convertize that in the classroom. Because if I don't go and convertize that in the classroom, grade 7, because this course is for grade 10, 11, 12, and 13. As Casey has said earlier, the problem that you have at the upper grades are coming from the lower grades.
So, yeah.
Yes.
That's why I'm looking at this and I'm thinking, this is really crazy that they don't know how to do this. And they're not able to think logically through that. I'm surprised that people at that age, and that's probably why they don't like the subject, because they don't understand it, and no one told them to think at the
They
lower.
don't. You are so correct. They really don't understand it. They don't understand the subject, and that's a problem. And we have to. So, as I was explaining earlier, the course is about looking at the CSEC report. That's why I need to get those for tomorrow. I think that I asked to carry, and we're going to see that some of these errors are errors that come every year. Students will make the same errors. Why are they making the same errors? So we have to look at how we instruct them to see if we can start to change how they think.
I think I won't be interested.
So because when students have 0.783 and given this for the answer, they should know that it's impossible. This answer is impossible. So they have to start thinking, if they're doing rounding, it's impossible.
Even for multiple choice questions.
Say speed that up, because I don't want you to say speed that up for me. Speak up for me so everybody can hear you.
No, I was just saying, even using the same decimals. When they're doing a multiple choice, yes, they're going to put 72.3 there. They're going to put all these weird numbers, and you don't have to calculate anything. You don't need to. You just eliminate. No, this is not right. This is not right. This is not. So it must be this one. Even if you're dividing, let's say 16.1 by 4. You don't need to waste time and work it out. Because you know, like this.
The answer is between 1 and 2. It can't be bigger than that. It has to be between there,
So if you understand the subject, they can more than pass the paper.
But they're not, I think that they're not understanding the subject. They're just seeing 2 numbers and I need to do an operation on the 2 numbers. They're not thinking like, what that answer should lay between this number and that number. But there must be, so students start thinking what the answer should look like. They need to start seeing what the answer should look like rather than just mechanically doing something and they're not thinking. But they need to start seeing that. That's important, especially for upper school. As Casey was saying earlier, that when they go to the multiple choice paper, what will happen is that all the wrong things that they could possibly do, the answer is there in the multiple choice waiting for them. So they walk into the multiple choice exam thinking that, oh, I did so well because I worked on the question and I saw the answers. But it's all the wrong answers because, yes, because all the wrong answers are waiting for them. Because the persons who are writing the exams are using these misconceptions to write as the possible solutions.
Yeah.
What errors they make with conversion? I'm going to show you an error that with order of operation that a lot of persons, even teachers, make the same error. So we look at BOMDAS. We use, is it BOMDAS? That's it, yeah.
Something.
Oh,
It doesn't matter.
yeah.
Yeah, I know, but when
Okay.
They know it as, I think, bedman.
Yeah, we know it as badness or canvas, whichever one we spell it.
Okay, so it's basically the same thing. So it is bracket of multiplication, division, addition, and subtraction. But this is the problem now. If you have 3 times 2 divided by 5 plus 4. So let's look at this now. And we should be using decimal now, but I'm not going to use decimal because this might not be able to work out smoothly because I just wrote some numbers. But let's look at what we have on the board here. What's the first thing we should have done?
Can you zoom in?
Can we zoom in, please?
Can we zoom in on the board, please?
I need to eat more carrots.
Which side?
Come on, the
Yeah.
other side. Continue.
That's
Back over the left hand side.
that's fine, right there.
Too
far.
far.
Ah, yeah.
See?
What's the first thing you would do here?
Multiply.
Multiplication.
Okay,
6
so
over 5.
if I had, let me change this a bit to see what it would have been. The first thing you would have done is what? Multiply?
No, divide.
That's it. That's
Okay.
it. Because even though you, right here is a problem for many
Yeah.
persons.
Yeah.
So even though they have BOMDAS, they think that you multiply first. No, it's a left to right sweep. So you will do your left to right. So which one comes first? Just like over right, left to right, sweep. Which one comes first? In this case, the multiplication comes before the division. So these two are interchangeable. So but you use how you write. Left to right sweep to determine if you multiply first or divide first. And it's a common error. You understand what I'm saying, kids?
Yeah.
It's a common error even with teachers. They just have BOMDAS. So some persons went ahead and they would multiply first. And then divide. No, actually, it's divide first because it's left to right sweep. That is important for students to understand.
Well,
So
It happens with the addition and subtraction as well.
Exactly. So even with addition and subtraction, it is from left to right. The order
Left
is
to
right.
right.
Right from the left to right sweep. That is how we do it. And I'm sure that most of us as teachers don't know that.
yeah.
So even us as teachers, we have to be careful. We have to constantly research, see how we put across the things. It's left to right. So even though there was subtraction pressed here, let's say this were subtraction and this were addition, we would subtract first because the subtraction comes first. So it's left to right, sweet. Jomo, do you have it?
Divisions first. But in the event that the initial problem have brackets.
Another thing, conversion. What are we saying? What is a conversion? What exactly are we referring to? Fraction. So they have 3/4. And they need to convert that. Let me use an easier one, even though. Aha.
That's easy.
Okay, alright. Alright, so they get 0.75. But the question is, how do they know that that is the answer? What do they do to get that answer? They went ahead and they kind of divide themselves here. And they put the 4 here and the 3 here. And they put a point here. Don't even understand why they put the point.
Zoom out a bit.
And it's in order to cancel.
Oh, they can't see the, can you? Okay,
You can see 1/2, can't see 3/4.
Alright, let me do the 3/4 first. So we know that this is 0.75, alright?
Yep.
So what they usually do if they don't have a calculator, what would they do? They put a point here and they don't even understand why they put a point. And then they add a 0 here, so.
Add a 0.
And they know they got 7 times and they get 28 and then they subtract. And they don't know why, but they added up a 0. And they, so, seriously, it's not the method that we really want to teach them. And that's the reason why they mix it up, because sometimes they put the 0 first and then they don't remember where the point, which part they put the point and when the 0 comes, so they do it vice versa and they get all confused. But even looking at this number here, I mean, huh?
No, it's change that percent.
Alright, so we'll get onto methodology for correcting these errors. You can probably show yours. Alright? Alright, so basically, before we move on to the other topics, we're going to look at how can we correct the errors that we started about. So let's take a break and then we'll come back after this and do that. So after break, we're going to look at how can we, the errors that we talk about, how as teachers we can guide our instructions to correct these errors. So just for decimal, we're doing it one topic at a time. For decimal, we're taking a break and come back. For decimals, how can we correct these errors so far? What can we do? What can we put in place? So you get our 9 minutes break. Do you want to do this first and then go for break, or you want to go for break first?
Break first.
Alright, so you have a 15 minutes break and we'll come back and do this.
Barbecue.
Number of times, number of times.
Hello? Hello? We printed two of those things? Alright, let me just try to separate them all.
I had it on mute.
Hello?
I'm here now.
I thought you guys were supposed to take 15 minutes, so you know you don't get your lunchtime, right?
Mr. McCarthy,
I didn't hear that.
we actually went to the computer lab to print off those documents you asked for.
Okay, so where should you got those documents?
Yeah, for the case, do you want us to print both the pure and the application format? Or just
Applied,
one?
it's called applied.
Applied?
Pure and applied, yeah.
Okay,
But you didn't have to print it, you could have done it later for tomorrow, because I didn't need
yeah,
to know.
yeah.
So where are the others?
They're actually coming right now. They, pure and applied math.
Adrian, are you there? No?
Yes, I'm here.
Alright, so can you just work on what I told you to do earlier? So you're gonna look at how methodology for teaching decimal. And this is the misconceptions that we've looked at before. You're gonna look at methods, how you can go about correcting these misconceptions.
Okay.
For tomorrow's class, are you hearing me, Adrian?
Yes, miss.
I don't think you were here earlier. For tomorrow's class, you will need this, or you can take a laptop and you can use the website www.cxc.org. So what you need tomorrow, you need CAPE and C-section exams. CAPE and
The
C-section
exam
exams.
is
Yes, you need CAPE and C-section syllabi. You need a CAPE report, and you need a C-sec report 2013. For June and May 2013. Can you repeat?
McCarthy,
Yes, ma'am?
they had a pure math and applied mathematics.
No.
Well, the pure math, the pure math. The school, the one with the pure math.
Oh, some school. Okay. The applied is the mechanic, the stats.
Outside of it, physics.
Yeah, what's that? I wasn't remembering this today. And the pure is the same calculus.
Yeah, calculus,
Yeah.
someone.
Yeah, no answer. Adrian?
Yes.
Okay, so did you hear me? Could you repeat for me, please?
Yeah. The exams can be from any year.
Yes, you just want to have a sample so you can work from that.
Okay.
And then you have the cake. Yes, Christina, did you hear that?
Yeah, I got the year, so we're doing pure and applied, right?
So you need the syllabus.
The syllabus, but I need the report.
So you need a report. So you need a CAPE report, and you need a CSEC report, but specifically for 2013.
Okay.
So that's January and June 2013.
I got 70 books there.
Yeah. Sure.
Okay, so right now you should be working at the. Are you listening?
Yeah.
Right now you should be working at your methodology. What would you do to correct these misconceptions for decimals? So that's what you should be doing right now, okay?
All right. Well, because the kids make decimal mistakes. What can we do to
So which one?
just grammar?
Line.
What in line?
You know how you have a line graph? And you make your own line graph first, give them a visual picture of
What goes where you mean? Like you put tens, hundreds, thousands, like that?
you know what I mean, like. Now if you have a line graph, and say for instance you do a decimal places, so they'll see like 1.5.
It might. I think.
How you could say, perhaps they could visualize that,
Right.
what the numbers look like, no?
That's one way, but I would
Let me see your thing.
I would think this is the CSC. This one's, I don't know. This is the examination.
But that's Kate, that's CSE.
That's CSC and Cape different. I would say,
But like I love the Kate one,
This
this
is
have.
pure mathematics, this is Caribbean CEC,
like, that's
right?
pure, that's the Cape. This
Okay,
is CX, this is
but they don't
CSC.
separate into pure or applied,
No,
but
they just do it, yeah, they don't separate.
they just have math.
They just have math.
How you name it, one, two?
That's what you the year.
According to the union. Right here, code
I thought it
of
was
secondary
access, you
education,
do pure and applied, which is I guess, but
CSEC, that one's Cape,
CAPE.
right? I would think if you draw a line, it says hundreds, tens, ones, put a decimal point, tens, hundreds,
So we have to
thousands.
type or do something different.
You see what I'm saying?
So we're like two.
So if you draw it like this here, you draw,
that's what I think.
And then how do you get the exact value?
Actually,
No, if I do that card, the misconception, I'll get the 32 points.
This is Kate.
Yeah, sure.
Alright.
Right, and it should be a Cape applied. The applied one that you have? Has Cape.
I don't have a problem. So wait a minute, yes, this one, so this is Kate.
Right. I usually do anything that's CS or whatever.
Okay.
see, I would do something like this here. This is the decimal point.
So when you take the pick it up, come out, it's who's there, you just go somewhere and pick it up, they tell you to pick it up?
Yeah.
And hundreds times by one.
Ones, like this is hundreds.
Or could they also do Dean's box coming after?
Yeah, but you could use the int box.
Or we could do that too.
For what?
If I,
What do that,
well, let's
garden?
have a, how to correct the error. That's because students have
About, there is that Eugene block.
to use Dean's block. Or you could do a visual graph, like a visual graph.
But that's how we would.
Right, that's how we would. But the Dean's blocks you can incorporate it in this. See what I'm saying? Like tell them use the Dean's block. And then
So we're going to put tabular.
yeah, tabular format.
And then.
But other hundreds, tens, ones, tens, hundreds,
So
thousands.
it's like that's what we do.
Right.
Right.
And you go in front. Tradition.
They still do that. Still do that. That's it. Like, I'm just thinking.
But
How
you,
about
but,
a line? A
but
line
you,
graph would be where it comes to, where do you-
a line graph is nothing.
Like in business, then how we, the line graph, that's kind of the line. There's a movement in the line graph, they could see, oh, you know, once, 0.75, 0.75 actually is a whole number. So you move on that, yeah?
That's true. You could. But I consider
Remember, Cynthia?
Cynthia.
Think of a croissant. Say croissant and then say croissant there. Cynthia. Cynthia, yeah. See, people go croissant. You make croissant, correct.
it's just us.
I thought that was your, we should do this, or people, we should do, but if your team is college, I have to buy you a gift. If my team is college, you have to buy me a gift. So I thought that was your gift for last year's college. But if you wanna get back to me because you know your team's gonna lose, that's fine. This is good, you buy me a gift for my team. I like that, we can do that. So that was your gift. To honor how the audio, you. Okay, so then I have to call you back. No, I don't want you to call me. Cause I'm out of plan for the people. So anyway, I guess it was 16.
How else would you correct it?
It doesn't, that thing right there, using, table, that's a table.
Tabular format,
Or tables. Things, one,
hundreds.
10, 100, 10, and you said graph. Maureen says that may not be.
It
Graph
is, it's
Some
fine.
people, it's some people's logic.
Yeah,
Don't you, you're making them think, and it causes them to think about what they're gonna do. It's workable. You don't have to.
That's the road.
I'm saying exactly.
Yeah, well, here the move my tree, that's why I put it right. First little one, kitchen, trees.
But there's no time.
If I ever get there's one section. Section, I think more to that one.
But as you said, suppose that
The other methods, come outside of the box.
That's one thing that. My next method is gym French.
Try that. It's a method I would use. That's a very easy method.
It's true, but I'm working what an hour.
There's no way across.
I mean, that's true, that's working on the ends of the
It's the place value, should be the place value. So whatever they get, I will multiply 14 by 20. So 20 by 4. That they can easily do. So if it's on 100, that means something must be in the 100 pieces. What's going to be a 10 pieces? Each of them hand that's my place for the need.
That's the part of it. When you, let's say it's one singular number, right? And you don't allow quarters to be
So it's saying that something must be in the 100. When you're writing this digit, the last thing must be in the 100 place. That's what it means. So it is going to be 3 times 2, 2. So it is 210, 2, 2. The last digit here tells you where the last digit is. What position it should be. You never know.
No, seriously. I was just trying to explain.
Tells you. No, it tells you if you have measures of 2 places. Alright, so if you have 3, 8, 5, it is saying that somebody last in what you 100th place. And if I'm not following the last digit here should be the 1,000, so this 5 here should be the 1,000 place. So how can I write it? This is the 1,000. So when we start explaining this circle, so they don't start carrying and so they won't place for the context. Ready? Are we ready? Are we finished working? Adrian, are we finished?
Not yet, miss.
Need some more time? Bermuda, finished working?
Yeah,
We have 3 solutions.
we have.
You have great solutions. I'm so waiting to hear them. So I will start with Bermuda, but I'm giving Adrian 5 more minutes. Okay, so this is the course. This is the course that you guys should tune because parents teach up at school a lot, right?
Right.
And your job, you was asked, what's the whole upper school?
Right. And what they can use is this tablet form to say, okay.
And then they have to show that, like, number 1.
But if you have a grade 10 and you do, if you do that in grade 10, you don't have a grade 12 and 13. So if you build that, so the whole idea, if you build the foundation, you have to there. So if you can take the time to build the foundation right there, because when you go calculus or pre-calc, it's a lot of algebra is strong. So you have to build it. So it's algebra, so what you're going to look at is how you connect with all the topics are connected. They're interconnected. So if you look at linear programming, it's connected to inequality. So if they understand inequality, they can do linear programming. Even on their own, they should be able to do it. And another thing that is connected is what graph.
They have to show.
So all the topics are so interconnected. Alright, I'm ready. Adrian, are you finished now?
Yes, miss.
Alright, so the first one the first error we looked at was the place value error of multiplication. So we had something like probably 1.4 and we multiply that by 1 and 2/10. So that's the next thing too. Even the way how we call the numbers can make a difference. So even though I say 1.4, we can say 1 and 1, 4/10. And 1 and 2/10. So that makes a difference how the students yes. So or they look at that number there with a value. So it's 1 and 2/10. 1 and 4/10.
Right.
So that is important. So Bermuda, what's your solution? What's your ways of correcting these misconceptions?
So you're multiplying 1 and 4/10. Well, we are going to use either the Dean's block or a tablet form. Like write it out as in a table. which was where you have 100, tens, ones, and a decimal point. Then you have tenths, hundredths, and thousands. So
So
that'll be
you
a
did-
tablet
did-
form,
So you use a deeds block,
right?
what you're saying?
Yes.
Blocks would be blocks. But
I'm
if
not
they don't
hearing
have
you, Rosina, I'm not hearing you, you're so far from the,
Okay, we're doing the deeds blocks, but if they don't have deeds blocks, we're gonna do a tabular.
uh-huh.
Like how he was just how Orenthus was explaining, using the row numbers to the left-hand side, to the right-hand side, and the tenths or hundredths on, sorry, the opposite way around. On the right-hand side is the whole number, what do you say? Left-hand side is the whole
Real
number,
numbers,
right-hand
tenths,
side is the tenths or the its,
Mhm.
the
and
hundreds.
then decimals in the middle for the tablet.
I think if you put it in a tablet form, they'll be able to see it better. So they understand where the ones are, the tenths, the hundreds. So if you draw, uh,
But a
I know you
righteous,
can
I
see,
can,
I know you can see this. Like that?
yes, I'm seeing that. But a righteous, my problem with that method is this. I'm seeing how that could work for addition, but I'm not seeing how that could work for correcting the error in multiplication. Are you following what I'm saying, everybody?
Oh, okay,
Yeah.
yeah.
So I see how it could work for addition, because addition there, it would be the digits have to be in the
Yes.
right place, and then you can rename or regroup, right?
Right.
So I get that, but I'm not seeing how that could work for the multiplication. Adrian, yes, Crystal, you want to say
Yes.
something? Crystal, do you have anything to add?
No, we just did the table and the deeds blocks. Can we do deeds blocks then?
All right, then explain to me how you, yes, we can do this one, but you have to explain to me. We could do anything you want, provided
Okay,
you can explain to me how you go about doing it.
The deeds blocks, you take it and make it into fractions.
No,
Um,
you would have to show what a tenth is. Basically, when we use deeds block. Hello?
I'm listening.
Oh, sorry. We were saying with the Dean's blocks, it's basically, that's where they have to understand the difference of what a one represents, the tens and the hundreds, and then what a ten. So basically, they have to understand that when you have one, you can visualize and show them that, one equals 10. Am I saying it right?
One.
What is one?
Equals 10. One
yes.
unit equals 10, sorry. So basically, when your units increase, when you're multiplying and you notice your units increase, that's when you know you have to add more tens or whatever in that factor. Am I saying it correct?
I'm not seeing how that would work, really.
No?
No.
Yeah.
Anybody else? Adrian?
How about
Well, this I would use a place value chart.
Uh-huh.
Yes, I would probably start with 100 tens, ones, and then tens, hundreds, and maybe include the thousands, right? And then I would have a separate column for the multiplication, but I would multiply them separately. What was the example on the board? 1.2, I think.
Yes, and times 1 and 2 tenths.
Well, I would actually use the ones, take the ones to multiply the 1 and 2 tenths, and then I would take that 4 tenths to multiply the 1 and 2 tenths. But when they get the answers, they will record them under the respective columns.
And then add.
Right? Under the tens, the hundreds, and so on.
And then do what? Add them?
what's the one?
Well, once they get the answers, miss, right, and they add them, they will be required to write them under the respective columns. Right? And there would be, for the chart, there would be a separator, a line where, you know, that would be the position of the decimal point.
All right. That could work. Anybody else?
How about fraction circles? I don't remember how they work.
Yes, tell me about that.
I don't remember how they work. I didn't really quite understand it, but I remember you told us how to do you take the fraction, you take the fraction circle and break it up into the fraction, the first fraction, and then you take the, I don't understand it, but I know we do, so I did it for my example.
Did we convert the decimals into fractions first? And then use the fraction chart.
Okay. Yes, so a good method to use is to convert, because the truth is all the math concepts, they're interconnected. So when you look at decimal, it's a fraction, but decimal and fraction they're the same thing. They're so interconnected.
Right.
So when you have once you want to define a decimal number, is a decimal number is a fraction with a denominator being a power of 10. Agree with me, everybody? So all of these topics are interconnected because technically a decimal number is a fraction. The only thing is that this fraction is unique because the denominator is a power of 10. So all I can do, before I start teaching decimals, it means my students must master what? Fraction. So I would rewrite this to 1 and 4/10. That's what that means, really.
Yes.
And rewrite this to 1 and 2/10. Because really this is 1 and 4/10. There's another way of writing 1 and 4/10. And this is 1 and 2/10. There's another way of writing. Can they see the board, everyone?
Yes.
Another way of writing 1 and 2/10. This is it. This is it. They're the same thing. It's the same thing, but they're representing a what? Another way. And it's another thing that we need to get students into. The same concept can be represented another way. So, could students be able to manage this? Of course. So this is 14 upon 10 times 12 upon 10. So this is what? 322 upon 100. Same? Thank you. I memorized this from key cells. Oh, sorry, my bad. I apologize.
Now you can just buy.
So look at this now. This is what they know. So this is easy for students to multiply, whether they have a calculator or not. It's easy for them to multiply all numbers. 14 times 12, they can do that. It's just a decimal point there that's giving them, where to put that place value that's giving them a problem. Now, when they get here, they know that this is here, the denominator is what? 100. It means that the last digit should be in the 100th place.
So, yeah, okay.
So the last digit should be in the 100th place. So how can I write this so that the last digit must be in the 100th place? So I need a digit for the 10th place. So this is my 10th place, my 100th place. And then I have my 1. So how can I write this? The 8 should be in the 100th place. 6, so it is 1 and 68 hundredths.
No, I would not have done that.
I didn't hear that.
Why we can't divide 100 into 168?
I didn't hear that, Regina.
She didn't show that.
I can't see your face. Could they show your face, please?
Go back.
No, only got your hand, like your hair.
Go back.
Yeah,
Right here.
And come over.
All right, so what are you saying now? I didn't hear that.
So,
To the right.
in calculating the 1.68, are you saying to the student, because it looks like you're skipping a step, in the sense that you didn't tell them how you got to 1.68?
Because if I'm saying, Rosina, I'm saying that the topics are so intertwined. So a prerequisite, remember last semester we looked at prerequisites and why they're important.
Yes.
So a prerequisite for learning decimal. There's no, you can't teach the topics in isolation. So a prerequisite for learning decimal would be the fraction. So if they understand how to solve a fraction question, how to multiply fractions or mixed numbers, then they should be able to do this question.
Yeah, but I'm saying when you get to the 168 over 100, we said that we had to divide the 100 into the 168 to let them know that that's what we're doing. We didn't show that.
We don't need to do that.
We don't.
We don't need to divide. Yes, we don't need to divide, but if you
Stay by
understand
the board. We can't see you.
Stay by the board. Go by the board, sorry.
Alright, stay by.
so this is it. This is where you're having a problem.
Yes.
Alright, so this is the idea behind this.
Like a student, if a student looks at that, they automatically, it's going to be assumed that they understand that that 100 is divided into the 168.
No, this has to do with a place value idea. It's a place value idea. So if we think of decimals, Rosina, as having a denominator of being a power of 10. So what is this? This is a decimal number. We know this is a decimal number now. Because what is that in the denominator? It's a power of 10. So how do we need to rewrite that? How do we need to do that? So this would now be, I know that this is 100 at the bottom here. So the last digit should be in the 100th place. So if I know the place value system or the decimal place for the system, I should be able to write that. Just look at it and write it down.
That's 10. That's 1.
So the place value there is important. They have to get the place value properly. They have to get the fraction idea properly for us to teach them the decimal ideas because they're all interconnected.
Yeah.
So if they don't, that's the thing. If they don't get the decimal, the fraction properly, and they don't get the decimal, and they don't get the place value, then they're going to have problems with the decimals. And that's what we're moving away from. We wanted to get the idea of place value. So they should be able to look at this and know that this is 1.68 without doing anything. You don't agree with that?
Agreed.
I think they should be able to look at it and know that. Because it's 100 at the bottom. It is just simply telling me that the last digit should be the 100th place. It's just simply telling me that. So even if I have this number, 3827 upon 1000, it is just telling me that this 7 here should be in the 1000th place on the place for the chart. So this should be, how do I get that? It should be 3,827,000. So it's the old place for the ideas that we have to get it properly. We have to get them to get it properly.
And where's the decimal going in that? Like, I'm still not getting it. I don't
Between the
see
8
how
and
the
the 3.
student is, how did we teach them place value?
How do we teach them place value? That's a grade.
That's a prerequisite. That's a prerequisite.
Oh, I see.
They should have the prerequisite.
Okay, now I'm understanding. Because I was just like, how do they know that?
That's the prerequisite for it. So basically,
Okay.
once
Just
you,
saying, because they're in 10th grade, so
Right.
they should know that.
they should know that.
Okay,
But the issue we are having is when she first multiplied 1.4 tenths and times 1.2 tenths. What happened was they have moved they have put the decimal point in the incorrect place.
right.
And to alleviate that, Ms. McCarthy changed both of them to fractions.
Right.
So children usually want to deal with whole numbers. So what you do is you say 1 and 4 tenths, right? Or you could have said 1 and, that would have been a bit hard, but you could have said 1 and.
So that's when, okay, so once we get this answer, we can then push it into is there a mindset? They can then put it into this pair that we were talking about earlier.
Yeah, they could put it into this here. Yes. Ms. McCarthy, just the way you did it, right?
Yeah.
From the, when you said I could have used that as addition, from that particular format, could I use the tablet form that I had earlier to use it in that area, in that situation?
I don't see how.
See, how do we get from, you're saying the 168.
How do you get from what?
So they still need to use the tab, or the tab, like, understanding of how.
Oh, that's what you're saying, alright. Yes. So if I have the place for the chart, this is what I'm saying.
Right.
So this is the one.
Yes, sorry.
I'm just following your orientals. So they have, alright, let's say tens, ones, tens,
Yes, that's what I'm.
hundreds,
Taking a mind.
thousands.
Yes.
But look here, this is not something that you would do if you're teaching this lesson because it's a prerequisite. They need to
Yes,
know this
yes.
already.
Yeah, I'm
So
just
if I
trying to
have-
get what's going on in their mind.
Right.
If what?
We just don't
trying to get
understand
out
what's,
what's going on in the student's mind so that they can understand the decimals. So
Okay.
go ahead.
So I'm saying that if I have 168 hundredths, I'm saying that the last digit should be in the hundredth place.
the space, yep.
So how do I get that? I start writing. So where's my hundredth place? This is my hundredth place. And what's the last digit there?
Right.
Yes.
Right.
8. So I'm putting my 8. What's the next digit?
No, I get that,
6.
but.
And the next digit is 1. So that's how we do it. That's how.
Right.
So it's a place value idea. But you,
That's just the individual person. They need to know.
No, yeah,
I
that's,
understand that,
that's a
but
prerequisite.
That's why she
Not-
said
if they don't know how to put, to me, if they don't know, if we're struggling with the issue with placing, putting an answer into the nearest, or to the second decimal point. If they don't understand that, how are they understanding this concept? If we don't put that up just so that they can logically see what we're talking about when we say 168, just as a prerequisite.
okay,
People with that
Rosina, this is what I'm saying. Rosina, it's just like if I'm going to teach multiplication, I need to teach addition first.
Okay,
Because I can't be teaching addition and multiplication at the same time.
right,
So I would have to teach
Okay.
the addition, and when they master that addition, then I move on to multiplication. It's
Okay.
the same thing. I would have to teach the place value concept first, and I would have to know the multiply fraction first. After I
Okay.
master those two things, then I
Yeah.
can teach decimals, because I can't be teaching
Yeah.
them decimals and place
Right.
value at the same time. Am I clear?
right, okay, yes. But we can still tie it in, after we taught it, and then we're introducing the new concept of adding the multiplication and changing the decimal to fraction. We can also just refresh their memory in bringing this up, is what I'm saying.
Actually, what I would do, because remember that last semester we looked at lesson planning, right? And how we go
Yeah.
about, and lesson planning and lesson sequencing, which is important. So what I would do is that in my introductory activity, I would test my prerequisites. So I would give them an activity to get them to get them to pull back, to bring back to their memory the place value concept and the idea of multiplying fraction. So you could do that in the prerequisite. But I don't recommend you to do that at the same time when you're trying to get them to get this idea of multiplying decimals. So you have to be careful, because if you're trying to do everything at the same time, then they might become bombarded and cramped. So they'll just mess up everything. So you have to do everything in a sequence. Following that?
Yes,
Yes.
Alright, finish writing? And so another misconception that we talk about is what? The rounding. That was the next one?
rounding.
And that's a multiplication.
Conversion. Oh, you get all of that? Rounding. That's between divine.
And we might say round to 2 DP. Or, yeah. And students will start to do things like, I give you this number. That's what we said earlier, right?
Yes.
And that's a common misconception with rounding. So what method did you put in place? What method do you think you could use to correct this misconception, Sean?
For that?
But this is it. Like, no,
Real life situation is a good one.
not it.
If you're wrong.
Tell us about like KZR.
So I would say, suppose the place still two placement, but no way is that number two placement anyway. Oh, they did 2.20. What? How did they?
No, she's saying the biggest error that happened to it
I know
is that I can figure
what
that
I'm
out.
saying. Right. What I'm saying. How do you see the rest? Because it's not digitally.
Pay back your money, and I want to round it out. I want to estimate to a close value. But I don't want to support maybe not necessarily this particular question.
But it's a good example.
Yeah, but
But it could make a mix of this.
I want to. I go at 7.38. But I want to pay the money. How much? What figure?
Write a cents.
Yeah.
You could write a cents. So that there you have 7 and 382. You can write it as money. How would you write it as money? So just ask them how they write it as money. So it's about dollars and cents. So even that alone can get them started to think another way rather than moving decimal point. Alright, so everybody did you hear what Keza was saying? Alright, so Keza was saying that if we have, for example, 382,000, yeah? And we want to write that as two decimal places. And we want to write it in 2 decimal places. We could talk about how would you write this money, this number as money. How would you write it as money? So how many dollars and how much dollars and how many cents? Clear with that?
Yeah.
Yes.
Yeah. Because when I talk about dollars and cents, I don't talk about 3 decimal places, I talk about 2. So it's basically saying that how would you represent this? You can have 3 DP, 2 DP. Any other idea? Crystal? I hope you're giving me some of that lunch just to cut and put on the table now.
I'm sorry.
It's going.
You want some?
She ate it all.
It's just an example.
Anybody else? Alright.
Could we use a watch, miss? A stopwatch?
Yes, that's a good idea.
Demonstrate that.
So can you be talking about minutes and seconds?
Yeah, but in this case, when you give them the stopwatch, say for example, well, one would have 100, one would go up to 100 on the stopwatch, another would go to 10, and then the other person would start from 1. So you'd have the ones, you would have the tens and the hundreds and the thousands if necessary.
Okay, yes, so how would they do the rounding? I don't get it. Maybe I'm just a slow sorry.
Say for example, you are at 382, right? Well, the person would, in the 1,000 column, would set his or her watch to
Thousands for TH, right? That's what you're saying.
TH.
Yeah.
Yes, that person would set his watch to 382. The
Okay.
next person would have, that would be 38, and the next person would have 30. You get what I'm saying, miss?
I'm trying to, yeah.
So when the person with the 1,000 watch actually starts his watch and it reaches up to 1,000, then the next person would actually be required to go to 39. But the problem there is that the watches might be moving too fast.
Oh, I see. I see what you're saying, but let me think about it a little. Let me think about it. I'll answer that at the end. Let me think about it a little bit more. I'm trying to see if I can foresee all the errors that might come from that concept, that idea, because You have to think what are the errors that students are going to pick up on or pick up. For me, anybody else have anything else to add? For me, I wouldn't teach jumping any at all. That's just crazy.
So look on it.
I don't teach like, because the decimal point doesn't move and it comes back to the place where the idea. The decimal point doesn't move. The digits move along the place for the chart, not decimal point.
Right. Keep going.
Are we clear with what I'm saying?
Yes.
So the idea is that.
Yeah.
I know you can, no man. So he's not.
Alright, what I'm saying, for me, I don't teach moving decimal point any at all, because that's a misconception. And once you start to teach just moving decimal point, for everything students will move a decimal point. Agree or don't agree? So I wouldn't teach moving a decimal point any at all, so I should never have my students moving decimal point, because I've never taught that before. So what I will do if yeah.
Now we show like let us do this on this. Now let's draw one vertical line and after vertical line and so use it to roll it up around.
How much numbers? What's nine?
What does it mean? What does this mean? What does it mean? What does it mean, you know? So why this can't be correct? So these are the discussion. Why can't this be correct? It's a different number from this one. That's a big difference between the numbers. So for this take out of the discussion. You have to discussion and discourse. So I don't teach rounding any at all. But I need to say things like, I will use a money example. If I have this amount of money, this amount, and I want to run this 2 decimal place, what do I mean by that? So I can use my place for the chart. I have my ones, my decimal point, my tenth, my hundredth. So it's good for them to experience. And then my thousand. This can't fit, but I guess you get the idea. So if I put in this, I put in my digits. That's what I would do. Once I put in my digits, how many decimal places I have? 1, 2, 3. What do I need to do? I need to write down to what? 2. That means 1, 2. So it means that it shouldn't be greater than 2 digits after the decimal point. So that's what it means. So then now we start to look at this number to say why it is. So we start talking about money. So money is a good one. For me, rounding, money is a good way. So if I have $1,300, is it closer to 1,000 or 2,000? So that's rounding, you know. So we have to have this conversation. 1,300, is it closer to 1,000 or 2,000? It's closer to what? 1,000. If I have 1,800, is it closer to 1,000 or 2,000? It's closer to what? 2,000. So they can round like that. But if I have 1,500 now, is it closer to 1,000 or 2,000? It's right in the middle. So for the benefit of the doubt, and we go up. So these are the conversations you have with them. Look at this number, it's 2. So is it close? What is the next? Is it closer to what number? If this is 38, or is it closer to 39? Sorry.
If that is closer to 3.
Is it 382 closer? So then is it close? This 2 here is closer to 38 or the 39? You know, that's what I'm saying? Am I making sense to you all?
Yeah.
Yes.
Okay, so I have this 3H2, this 2 here. does it make it closer to the 38 or the 39? 38, but if this were
38.
6, it is closer to the 39.
39.
So that's the whole idea. What is it closest to? What is it closest to? Huh? Are we following that? So what is
Yeah.
it closest to? So it's the same idea we're talking about rounding. What is it closest to? And if it's midway, then we round up to the benefit of the doubt and we round up. So if you have $1,200, it's closer to 1,000. So when we round that, we round it to 1,000, don't it? So if somebody owes you $2,000, if somebody has $1,200 for you, they give you 1,000. You say, all right, you can work with that. But if somebody has $1,800 for you and they give you 1,000, then you're gonna frown, don't you? Tell the truth. So what is it closest to? But if you give you 2,000, you feel like it's a little bit more fair. So what is it closest to? That's the whole idea when you talk about decimal rounding. We all clear with that?
Yep.
Yes, miss.
All right. So I hope you see how the language that we use in the class and how we teach things, so, how we can cause the students to make some errors. Because once we do this, trust me, for everything, students are going to do that. So we just don't do that any at all. Because this error is a common error. To move away from this error, we just don't do that any at all. Follow me, Adrian?
Yes, miss. Sometimes I even leave the answer like that.
That is so
You
true.
understand what I'm saying, miss?
Yes! So just don't do that any at all, because they have a problem with that. So just don't teach that any at all. So if you're teaching multiplying decimals, how do you teach it then without doing that? So I have the same number, 7.382 times 10. What you need is a place for the chart. Give them a place for the chart, or you put one on the board. So it is what? 100. And it's faced to these tens. And let me just use 100 tens, ones, point, tenth, hundreds. Alright, so before you even start teaching them anything, this is what I would do. And that's why conversation in math is important. I would start to know, if I'm going to multiply this number by 10, what should I put to the number? What should I put to the number? By how much? It's 10 times. So without even doing anything, without even calculation, the student should know that if I multiply 7.38, whatever the number is, 7.382 by 10, it means that the number is what? 10 times as large. So when they start to give you numbers like 0.738, because they don't know they should go to the left or the right, it is saying that the student doesn't understand, it's doing the thing mechanically, you're not thinking about it. Because the number should get 10 times as large. I know that that answer must be wrong. So I put that on my place for the chart. I have 7382. Is that correct place on my place for the chart?
Yes.
Yes. So if the number is 10 times that, it means that each of the digits is moving one place up on the place for the chart. And this 7 is in the ones place, so it now goes to the what? Tens. And that's my plus. This 3 is in the 10th place, it now goes to the ones. This 8 is in the hundreds, it now goes to the 10th. And this 2 is in the thousand, that goes to the. So what is that number? 73.32. So each of the digits. So if it were 100, the number here tells you how much time it moves on the place for the chart, by how much. And if it's division, the number should get less, so it moves down, the digits move down on the place for the chart.
Also, can we, is it incorrect with McCarthy to say it only moves by the number of zeros that are in the number that you're multiplying by?
You can't tell them that because it's a power. Because if you think about 10, that 10 there is 10 to the first power. So it's that to move one time. If I have 100, it's 100 to the, that means it's 10 to the second power. So the power tells move down on the chart. So when math now is announced in of itself, so they tell you what to do, you know. So if I have 3 times 2, 3 to the second power, this is saying that I'm multiplying 3 2 times. So these are the things, the meaning of these things, I should understand. I'm multiplying this 3 here 2 times. The power here tell me what I'm doing to it, how many times. Are we clear?
Yes, miss.
Yeah. Did you learn anything new so far?
Yeah.
Learning new tricks.
Yes,
Teaching children.
They're tricks? They're not tricks, they're just maths.
New methods, new
New
strategies.
methods, yeah,
New strategies.
that's new strategy. That's the word. New strategy.
Alright, so do you think that if we use this method, it will eliminate that moving of the decimal point thing that everybody would normally do for everything? That will do for everything if we use this method?
Yes, miss.
Yeah,
Okay.
I think it will work. I mean, I think it would correct a lot of the mistakes.
Yeah. And so what was the next? We talk about convert. So we look at the place value, we look at order of operation. The next one was what? Conversion. Do we look at that? Yeah, man, we look at that.
But we didn't.
Oh, we did not look at it, yeah. We didn't. Did you finish? Did you get to write?
No,
Look at this. I have a half that I need to write as a decimal. What is a decimal? It goes back to the idea. We talked about concept last semester. What's the concept of decimal? The idea is I need a number being a what? A power of 10. So all I need to do is to write an equivalent fraction for this with a power of 10. Equivalent fraction for a half with a power with the denominator being a power of 10. 5 upon 10. So 5 upon 10 is the same thing as what? 5 tenths. That's it. Follow that? What about 3/4? What do I need? I need a what? I need an equivalent fraction where the denominator is a power of 10. And what is that?
100.
So it's 25 upon 100. So in this case, I'm multiply that by 5 and that by 5. I'm multiply this by 25 and that by 25. I get equivalent fraction. How can I mean that this 5 is in the what place? 100 is the same as? I think this method is better than doing this.
Yeah,
And I put a point here and I don't know why, but I add a 0 and I don't even know why. And then
the problem is the same problem. Kids, they take kids.
Adrian, do you understand what is happening?
Yes, miss.
Follow that?
Yep.
Bermuda students, do you follow that?
Yes, Miss McCarthy.
Crystal, follow that?
Yeah. Parts of it.
She's saying converting from fractions to decimals.
We see you scratching your head. We don't see your face.
We see your hair and your hair.
face. We don't see your
Go
face.
back, go back.
We like looking at your face, Miss
At the
McCarthy.
board, at the board.
Oh. So, what were you saying now, Crystal?
It's like, yes, I do understand the concept, but I like to see your face.
She's saying
That's the month.
that's better than communication. Because what happens is a lot of
So they would have to know the multiplication.
Yes, that's what I.
that's it's a prerequisite. It's all about another number, age is start good age.
Equivalent fraction is one of the first topic that they would have done in fractions. Because
Right.
if I go into the primary school by grade 2, they do equivalent fractions. So by the time they need to get to decimal, which is probably grade 4, so they should be using what they know from grade 2. Because as I said before, they are so interconnected, the things are interconnected. They can't be done in isolation.
Convert to a time door.
Yeah.
Because those most gonna have
And
to
then
use
it's
a
a
fair
fair
Yeah, so they need to know all of the, that is that. They need to learn just some of the facts and the skills, and they need to know some of the concepts before they can do other concepts. Alright, moving away from that, we're looking at linear programming, which that's a CXC topic. So remember that our focus is on the CXC topics. So we're looking at linear programming. So you wrote on the likely errors. Alright? You did that earlier, right? Right?
Yes.
I'm not reading this. Right. So for those of you who didn't do that, you're going to write down the likely topics, and as soon as you finish that, the likely errors and misconceptions, as soon as you finish that, then we're going to look at methods for correcting them. And guys, I would pay attention because something like this is your assignment. To look at the report, look at the errors, and see how you can correct these errors, what you can do to correct these errors. So I'm giving you methodology for the CSEC, so you guys need to be open. So what you can catch to put on your paper. So remember, you look at the linear programming now. So the likely errors, if you didn't already, then you're going to look at misconception for correcting the likely errors. What would you do? So many What's the understanding?
It depends. Like sometimes but like sometimes our group when I really that strong. When I really like when I make sure some of the 2 questions out of section 2.
You are your son's individual. We had to do it for the entire island.
Exactly. But it's still just middle school. You're not still getting the full statistics. You ran with that.
So you have to get the full statistics. You're right. You have to.
Remember strong group.
But linear programs are something that I think that a grade 9 should be able to manage. If the programs are in place.
Yeah, well that's the thing. Sometimes you can find is that
If the programs are in place, they should be able to manage it very well.
what come out is how many which one grade and the other. Like sometimes you know about the low less than so.
So you need to tell me, so the error there is the slope, looking at the slope, is the positive slope or negative slope. So if the slope is going up, whereas above it, and it's going, you know, so I think that is, I have that problem too when I'm teaching inequality, change the region,
Yeah, I
whatever.
didn't realize it because what happened.
So that's a major problem with it. So you have to look at the slope, how it's slope. So if it's going up, where is above and where is it going? It's going down. So you need to think, is the positive slope or a negative slope? That's important.
Is this all then? Yeah, I'm just saying, when you guys get sit down, I like that, the technical teacher was getting really good to see what I'm going to do, and I'm going to do something. Have a follow-up. Yeah, no, you didn't. But
Well,
no, you didn't.
like high school and
I think you have a positive slope.
very often is to see like high school.
It's really from that, but I don't.
Grade level.
I don't know if it's different.
Actually, in tests can end up term test of certain grade level. Because it specifies say must teach.
Okay, I like bearings. I'm not, I have to really love bearings.
So because it specifies so I will teach,
Are we just
must teach. That would have
I know.
can't go around
But you should push your students, man. It's fine.
No,
Push
but
them
man,
hard.
but
So even though you have to come
like
with this,
this-
if you see that they can, because
like this group have a strong group of teacher. Well, I was a teacher, but like, they have another group of the kind of weaker. And then, because you know what, forget about that, just go over some basic. It's a certain basic
things
factorization. Some of the aspects more
and
time.
factorization come every year, and you're gonna see on the report, when you get the report tomorrow, it's a small percentage of the students who actually get 100% correct. Very small. And they do some craziness. For example, if they have 2x squared plus 16x plus 20, that divides through by 2, the factor by 2.
So, yeah, that's what they're like expert.
And if, yes,
I forget about the 20.
yeah.
So,
It's a whole, that is some. What do we do?
so sometimes
So that's all factorization is the next thing you want to get here. Look at what we should probably start thinking of.
But that's part of the thing. Okay. Yeah. I think it's done. Exactly.
She's not in her way.
She wasn't on non-service. It's not really,
The mayor,
Stop talking on this. You're guys time to come up with ideas.
They have nothing. Hi, come on, dude. This is supposed to be my mic. Oh, cool.
man, this one is courage, Charles.
I'm not asking this. I think we'll be
Look,
For example, fraction shouldn't be up because usually fraction is one of the first top and when we look at the C7, some of the errors that we see, like I want to make papers, that's some of the common errors that we see. And if these errors are so common, but each of the errors, what would you do? How would what is how would you put across this for them to not be? You're just having a hard time understanding. Yes, sir. As you said, we can quality question in there. Yes.
and Jesus,
Yes, look here, our names are spelled down. Yeah, man, it's terrible. Here it says sometimes Jesus will and so the students, what they're doing, they get sent on past papers and they're sweating, they don't learn anything. So when they come to grade 7, they can't, and the adding fractions and correct and damage and give it to you because they don't always just swap answers. Sometimes they know the answers and then you have a question back. So the questions come back.
oh, so that's what
This is what you're working on papers and then if you question yesterday, you're going to see them back on the exam. It's serious. No, middle school training.
And I think because it was perfect. Actually, interesting. I would go to Washington. Have you done Washington one language? Give me a voice to do that. That should take, you figure out what her one language is and what she wants. And then she has to do, everyone has different needs. Say whatever her needs are, that's what she's doing. Most people tend to tend to be, right.
But yes, so this is just saying that this one here, one question should be in the 100th place. So you must need something to hold the position of the other two. The 10th place, and like 0, so it's only 1 0 to the G. So you have to understand these are basic ideas, the place for the ideas that you need to get. So when she was saying that you couldn't, you have to put up, no, they should not put up a place for the chart, they should get that before.
Who got turned on here? I wouldn't go to talk to that.
And it's just a math. The science people, that means the
Stop.
No, it's pressuring. So my, essentially,
Logically, you just, I would say, once what they make the sense, it goes to learn.
but she don't learn. She just because you have to practice a little theories, because they said that Piaget tell you that the students are not at that abstract stage. They're not there.
Supposed to learn or not for the learning.
Why they need to do these
They don't know that it's not there. What is it not
Why
there?
they need to learn?
Too much.
That might not be
But show that person make one and sexy.
Yeah, so that's
That's
why.
one of it.
Yeah.
Right. You have children going to GSA classes from now, GSA classes and not every week. Same one, in a 6 year.
That's much.
No, as in, them just go on through the system. Movement in the GSA, them just find a private school, after 6 years.
And then they give you analysis.
I trained math teacher, so I know that I could see his math chat. Yeah, that makes a difference for me. But in terms of that pressure thing, I don't think I think it's purpose. I wouldn't do that. I mean, like, first of all, I don't care, like, if you go to Immaculate or whatever, it's cool. But at the end of the day, I think I can learn English. Because I went to a technical high school, now somebody said to me, you went to technical high school and you're doing so well? And I was like, this is just like, oh, should I joke with this now? It's like disrespect or stuff. Like, I can learn anywhere. It's just that when I was in primary school, they tried to set up my brain with all this stuff here. I don't get any of this. When I started to learn now is when I started to sit and relax and look and pay attention. I started to understand. I just want to relate to these things. So that like I was just done, I'm done. Just can't relate to it. Just do things for me. You can learn anywhere you're at, anywhere. Otis Brown, you know Otis Brown. He went to something that was going to very, those who went to very close and acting like that, whatever you want to call it.
Kind of works. He was trying to work with you, right?
Exactly. Okay. Energy matter everywhere. It comes straight down. Right? The peak. So when they do GSA, they peak early, so they get good grades. Then it is down. And we settled a lot of other marketing. But you have persons peak late, so they peak. And some persons peak and they stay up at the plateau, stay there.
Yes, so what was his response? Still.
Oh, they say, oh, when the Lord is not himself, the Lord.
You, why are you sitting in the cell phone? Sir,
Because you're, I mean, asking first.
I'm listening.
That was sorry. So,
They shade academia for the audience want to be much more whole than
Alright, so I have a thing that said going up here is a positive grade and coming down the negative grade. So if I'm going up here, whereas it would be above the hill, on top of the hill, and below the hill.
one of the things is teaching other things. I think teaching, as we said before, it kind of isolates from this and things in a sense. Alright, for example, you teach part of the algebra and then you probably jump to some part of trigonometry and you end up jumping all over the place for complete syllabus. For me, like for example, when you mean line graphs, I just do straight graphs. I just make right through the graphs. So the like distant time graph, velocity time graph, the linear programming.
Okay,
that's part of interpretation at the same time. So things like upward slope and downward slope, they get all these concepts from the beginning, and then when you're moving through now, you're fine. Because it's not like learning it way last year and never really understand what they do. And but here, for us out here, I think we kind of do it kind of opposite. I don't really like the way how we teach. In terms of the topic selections.
But look here, that's why the sequencing of the lesson is important. The sequencing of the syllabus. Because that's one thing we're going to look at. When we look at the syllabus and we're going to look at to see the sequence. Is that we're satisfied with how it is sequenced as they give it to us? Or is that we need to tweak it? So yes, you can satisfy the needs of the students. So sequencing is very important. How we sequence. And as I said before, you can't, if students don't have the purpose, you can't move on. You're going to have problems. So you have to understand certain basic things. Cognitive stroke, native stroke, that is important. So you have to understand that, you know, top of the line, top of the hill, bottom of the below the hill. Top of the hill, below the hill. Consider, you know.
No, I'm just about the hill.
This is upward, this is it. So this is a positive and this is a negative. I'm going up here. Which part I would walk? I walk at the top of the hill. So this is above it. And this is below it. So if this hill is coming down, which part I walk? I walk on top of it. Below. That's the idea. But they have to prerequisite have to must as a teacher. Yes, my 2015 year.
This morning I was telling you agree. When you come here like it's a 25th year.
That's what he said.
No, I think basically know that. Like because the rules, the vibrance, and the development, the young. Most of the teachers who I know who teach for 10, 12 years, they just go.
Baby stuff, real baby stuff.
Is they listening?
That's when I'm on.
Yeah, so.
Alright. Are we ready? Done working? I need some more time.
No, I need to approve.
Adrian, I'm not hearing you. Are you finished?
Yes, miss.
Alright, Keza, come this square. You're alright, team. Let's take from the others, alright. So we look at the misconceptions and the likely errors first. Bermuda, what did you come up with?
Why do you always start with us?
Alright, I will start next time, I promise.
Language barriers or mathematical jargon.
The jargon, the language of math, that's what you're saying. That's a good one.
Yes.
Yes.
Two concepts.
Donald. Donald is saying next.
For the misconception in your programming, they basically don't know, like, the area to shape, or interpreting the questions of not knowing the area to shape, or not knowing when to, like, change sign, and basically some of them don't even know what is greater than this.
Inequality sign. not knowing when to change the sign?
Yeah, as in like, they don't know that.
When you divide by coefficient, that's what you're saying?
Not necessarily when divided by a negative or positive number, but
Yeah, the coefficient.
in terms of, alright, so they have x on the right side is greater than a number, and then on the right side, most persons tend to want to, they feel comfortable with the x being on the left side, so they switch the x from the right to the left and the number from the left to the right without changing the sign.
Oh, I see. I've never seen that one. I understand what you're saying.
X.
X.
Yeah.
And red. So they don't realize that it makes a
They
difference.
don't, yeah, they don't recognize that makes a difference.
I'm trying to make let's see.
Because normally once I teach them that once you divide by a negative number or multiply by a negative, the sign changes.
No, it's been
I
around.
normally see them make the effort to change the sign.
You tell them why
This is
though.
the error.
Yeah, I tell them why. I normally go through and explain. They hear me. I normally go through and explain everything. Like them don't hear me, they go to the chat.
Or is it, I'll make them test it to carry them to a test.
No, I've never let them test it, but I normally explain these things sufficient.
But explain, if it comes to class, semester class, I don't know, the explain is not teaching.
If I had only been there.
So it said inequality signs and the,
Job,
Adrian, what did you come up with? Possible misconceptions for linear programming?
I had something similar with respect to directed numbers.
hello?
It's similar to what is written to the left of the board, right? For example, you know, if you had minus x and you were going to write that as positive, then students normally wouldn't interchange the sign or the symbol there, the inequality symbol. Got that, miss?
Here is negative, and you want to make it positive. So because you change the value here, the value here is going to be changed. That's what it does, you know. If you want to divide through here so by -1, this here is going to change to a negative, and this is going to change to a negative. So if everything else changes, this must also change. Because if you should plug in values now, you realize that the statement would not be true then. So that's the concept. So you can get them to test it by plugging in values to see if the statement will be true.
Negative, try negative.
Yeah.
And then multiply by negative.
How about one other one, Ms. McCarthy?
Yes.
Would reasoning, in a problem-solving one be, also a barrier? I mean, an error?
That would be a difficulty that they would have, but I don't think it would be a likely error or possible misconception. But
Okay.
that's a difficulty they would have to have learning, and based on most managing wording questions, they don't know how to read it and interpret it. Alright, we're gonna write anyway, interpretation, even though we don't have any methodology for interpretation. So that's a likely challenge that the student would have. And this is a language thing, you know, this is an English problem though, an English language thing.
Oh, cutting grass.
Okay?
Put labeling the graph correctly.
Okay, she has that, that's in the graph, that's in the graph. She has that up there.
Miss,
Yeah. One in one.
we have deriving inequalities from statements or facts about the question. You are saying that would fall under interpretation.
I'll put it in an interpretation.
Okay.
Yeah. Alright, so how do we go about, thank you Kezia, how do I go about correcting these misconceptions of the language? Let's look at the language. Well, let's look at the language that they use in linear programming, JOMO.
Less than more than.
They use less than.
Yeah,
At
no
least.
more than. No more than.
Come kids, come back. That we look at some of the words that we see in linear programming, and then we're going to put a simpler meaning to it. Put a meaning to it. So we can tell them that these words, even give them a word list and a meaning, because we use vocab. Remember when we write our lesson now, we need to have a vocab in there. So for the vocab, we can give them a vocab.
McCarthy, I didn't understand that, Miss McCarthy. You're getting a little fast. That's a little bit backward.
I'm saying that for linear programming, you'll see word like at least. Let's think about the word at least.
At least.
I have at least 3 pairs of shoes in my bag. What am I saying?
3.
I'm saying what? 3 or more. So at least means greater than. Equal to or greater than. I have at least 2 handbags. So I have 2 or more. So it means equal to or greater than. So they can start to figure out which side they're going to write. But they said, what's another word they use in it?
No more than or at most.
At most.
What do they say on game?
Probably the same.
Most mean what? Less than or equal to. So these are the terms that they're not getting. At most. The most I have is 2. It means that I have 2 or less. What's another word that I use in linear programming? The same. What does the same suggest?
Equal.
So they can start to know which side they're going to write. What else they use? No greater than. What does no greater than mean?
Same.
It's less than.
Less than.
Less than. So if we have to think about it this hard, think about the students. And so I see, but I realize when they say at least, what sign is they normally write? Less than or equal to. You don't think so? Yeah, so the vocab there is important. So when you're doing linear programming, you need to go through before you start teaching, what does each of these words suggest to you? What do you understand by these? Clear?
Yeah.
Yeah.
Clear, Adrian?
Clear, miss.
Okay.
I was suggesting one of the ways to help them to clear up this is ask them to use an incentive.
That's a good idea. So one of the ways we can have them use an incentive is we can put a chart in the classroom with these and use them incentives, sentences, all of that. We can do all of that. But I need to know what these words mean. As simple as I see to them, because some of them they can't relate to the words. Adrian? Adrian?
Yes, miss.
Do you see sometimes students have problems identify which sign to use when they see the word at least or at most?
Yes, miss.
Okay.
Miss, I was about to ask, what is, can you think of a way where you can tell students how to remember what each of the signs mean?
All right. I'm going to like the greater than the less than sign.
Yeah, because
It's not different sign. It's one sign. That's the thing. It's one sign. If they start to teach different signs, then they're gonna confuse them. So they teach one sign. We're gonna do that next.
Moving on to the inequalities.
Alright, yeah. Are you guys writing?
Writing greater than.
Are you guys writing?
Yes.
Yeah, I'm finished.
Finished. I'm finished.
And let's look at the sign. The inequality sign. And this is where students get confused because as a student, I was confused with this for a very long time, which is so unfair to me.
I know what I did.
Not yet.
I used to say, instead of using the words less than or greater than, someone taught me that the mouth is always facing the larger number.
That's one way. That's true. So it's one sign. So we don't give them one symbol for less than and one symbol for greater than. It's one symbol we use, but it's how we read it.
The two, it's
Yeah, it's just one sign.
It's one symbol. One symbol. It's not 2 and 3. Alright. So
But you don't
look at it.
They need to zoom in some more.
Zoom in a bit more.
Yes, ma'am.
I'm gonna write some numbers.
No, come back.
This is one symbol. Right there is fine.
Alright, so I have some numbers. Can you see the board? Can you see the board?
Yes.
Yes.
Alright. Of these two numbers, which one is bigger?
5.
5.
5.
And the 3 is smaller. So if you notice that even before when I'm doing inequalities, I don't start with the x or whatever. I start by simple numbers. These are things I can already relate to before I start getting to that. There was something. So the 5 is bigger. So I put 2 dots. Which one is smaller? 3, I put 1 dot. Then I join them. So I can read it from both ends. 3 is less than 5, or 5 is greater than 3. Where the mouth opens and the 2 dots is greater. Where 1 dot, it is less than. It's the same symbol. I can read anyhow. 3 is less than 5, or 5 is greater than 3. It's the same symbol. In this case, which one of the numbers bigger?
10.
10. Alright, so the number that is bigger, I put 2 dots. Which one is smaller? The 9. I put 1 dot.
9.
Then I just join them. Because they need company. Ouch.
Like that method, miss.
So, what is bigger? Which one is bigger? So the 10 is what? Greater because that's where I have the 2 dots than 9. And the 9 is what? Less than
Yes.
10. That's where I have the 1 dot. So you don't teach about which sign mean greater than or which sign mean less than. It's going to confuse them. Are you satisfied with that, Adrian?
Yes, miss.
How you do your equal sign, Ms. McCarthy? You still see that?
It's just the equal sign.
No.
But Crystal
What she said.
just came up with an idea. If you have an equal number, you still can put 2 dots on the, because both numbers are equal. If you put the dot, the 2 dots beside both numbers, then you draw the line to each other.
Yeah.
Using your same symbol idea.
Yeah. Congress again. What are the students look at? They look at integers. What about integers that don't case they will wait later, right? So you can't be under pressure still.
Reach. Are we finished with this part?
Yes, you can read.
Yeah, done.
Come, Mr. Already. I think it's easier. Because we can get another teacher. The 130 and a half. Yeah, I think I did know for lunch days.
Yeah.
So,
Interludes.
I don't know, what about integers that I don't get in linear programming? I don't know.
So wait, who suggested integers?
I don't know.
They were saying something about
Integers. Oh no, we discussed that already. Didn't we discuss it already? So you divide by negative coefficients and everything change everything. You have to change the symbol to it because then it won't change anymore. Yeah, that's what we're talking about.
Alright guys, we're forgetting integers, alright? So probably next class.
You want to do integers?
No, miss.
We did integers last semester. I think we did integers last semester. We did
with the
counters. Yeah, we did integers last semester. I don't know.
But
Look here.
Miss,
I have this problem.
integers, for the integers, miss,
I don't know what are integers, what linear programming. I don't know how integer is related to linear programming. I didn't see how. How?
let me give you an example. Say they are supposed to solve a problem, miss. The common misconception comes in where students constantly say a negative and a negative gives you a positive whenever they are solving the inequalities.
Okay, but that's kind of like a general thing for every topic, not specific to linear programming. That's just an integer problem students have. They just don't know how to work with integers. So it's not a linear programming misconcept. You get what I'm saying?
Oh, okay.
Do you understand what I'm saying to you, Aidan?
Yes, miss.
It's a general thing across the board. It's not specific to linear programming.
Okay.
And we did have integers last semester when we were using the counters. I don't know if you were here for that class. Two color counters and we formed 0 pairs. You remember that? Yeah, we did that last semester though. I can't say that. Alright. So interpretation. Now, I myself as a teacher having a problem with getting students to interpret the question properly. So when I figure out the solution, I'll tell you. I can't, the only thing I can do is just basically ask them to, I go through, read the question several times, identify important terms that are used, but outside of that, I don't know what to do. I can't because my students have the same problem. There are times when I'm reading a question and I have to say, listen to me. It's like doing so and so and so and so and so and so and da 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 da. You know, I have to really get patois-ish. It's this. It's like, so it's not. So I'm having that problem. It is a skill. It's a language skill. It's really a language skill. So you know how students can read a common word, but they cannot comprehend, they can't tell what they read about? It's the same thing. It's a language thing that comes over into the math classroom.
And how about comprehending the message?
That's what I'm saying. I don't, they can't.
Yeah, I mean, in interpretation, we can call it comprehending messages. So, get the same solution.
Is it that they don't understand the math jargon? I'm not sure.
Sometimes it's not even, because if it's a math jargon thing that can be fixed, you can fix it, readily fix that by exposing them them to the words by using a vocab and expose, by just giving a vocab list and expose them to the words. But most times it's just simply reading the question and being able to interpret the question to see what the person is asking you for. And that's a skill.
There's a part of the linear programming question, like after you draw the graph and you shade, and you talk about the profit. Maybe that's, I don't know if that would probably be more math based.
I'm thinking.
Where like you have to look on
the diagram with the shade, the different vertex, and see with the coordinates and which one give the greatest value.
right.
I think that the candidates, they don't have a problem interpreting that, unless they don't know what to do. But in terms of reading the question and being able to interpret that, I think that I don't think they would have a problem.
For example, suppose if the shape looks like where it's probably not so easy to know whether this is the maximum, is not maximum or this one. Maybe that should be.
So that's how you test it in the equation. That is actually how you test it. I've never really seen students struggle with that, but I don't know.
Oh, because you probably think that if they can interpret the question,
That's what I'm saying.
that's enough.
When they get here, that's when you're plugging substitution. I don't really see they have a problem. Once they get to that far, they don't really have a problem. Because it's merely just taking the coordinates and plug it into the equation to get the maximum.
Probably it comes down to the IQ of the student, miss.
Yes, tell me more about that.
Students with a higher intelligence quotient normally do better at interpretation.
I hear you. I think that it. Let me think.
I don't know. I'm not saying that I disagree with the whole intelligence quotient thing, but for me, I think where the problem starts is from the children who were young. They weren't really engaged to think or try to interpret things. Things were always given to the students from the early coming up. So by the time they reach that stage, it's the same spoon feeding they expect you to pick out the stuff and tell them. So when I started working with my 10th grade set, what I had to sit down with them and teach them was that when you go through, you reach each sentence piece by piece, because what I initially had to do, the first test I set with linear programming, I had to outline the conditions, not putting them in a paragraph or a sentence thing, but I outlined the conditions and they easily did it. And after doing that for a while in class, and you put it into the nice big paragraph, they were able to go through and pick up the stuff. So it's because they weren't really taught to interpret stuff
And
from
it's the language
before.
things, the language are really.
They were swatters from day one.
No, I think that students read. So it's the idea of what we call reading, you know. We think that let's make you call all the words. The student can read, but that's not reading. That is calling words.
Right.
So reading, but I read the calling words without any understanding. So it's the same thing. So if I give them a passage to read, I should ask them some questions that they need to infer, some deductions from the passage. They're not reading between the lines and making conclusion. So when they come to the math class, it's the same thing. So I'm seeing it's a general language problem. That's how I interpret it to be, rather than a math problem. So even when I go to the social study
It's a
exam,
general problem for you.
when I go to the social study exam or any other class, I've even been given an assignment and it's a reading assignment. Like for example, what is so and so and so? And the student would not even do the right definition, so the student give an example. It's just showing that the student is not interpreting the sentence properly. It's not even a math question per se. Plotting graphs. It's like a short area. Plotting graphs, what exactly do we mean by that? Then the label, you see?
Because, for example, if you're going to talk about big numbers, because I noticed some of the linear programming, you have like 300 with those numbers in it. So that pulls that.
So it's a scaling, they don't know how to, that's the thing.
Scale, yeah.
The scale, I think that while they will mix up the x-axis and the y-axis, and these are just math facts, so it's when you know it, you don't know it. There's nothing we can do about it. That's a fact, math facts. We're talking about math facts. So the math facts, that's something you know or you don't know. I can't do anything about that. And that the x comes first before you got the x, the first one is the x and the second one is the y. That also is a math facts. There's nothing I can do about that. You have to ensure that you remember that. That's a math fact. Are you agreeing with me or not? Definitely a math fact. So that's just I can't do anything about that. You, the student, have to go and ensure that you get that. But in terms of the scaling now, that's a big aim. Especially when you need to put on as much against like 1/3 to plus against 6. Now you have headache in the class. Now we have headache because guess what? They can't count up the in thirds. And when they can point something, they can't count up in thirds. So I'll say, okay, so this is my 0 point. If I'm counting thirds, 2/3, and then this is 1. They can't count up in thirds. So when you need to put that 1/3 on the graph, then they will have a problem. And even if this is 1, so even if they have 1 here, and they need to find 1/3, they don't know how to find that. That's a problem. So this year, I'm saying, look at this. Divide the 3 equal parts and you find 1/3 out, and one of the parts is 1/3, the first part there. So it's a whole host of problems that our students, when it comes down to scaling. So so I see the major problem for scaling is when you need to put decimals on it and fractions. So when even if you put in 3,000, it's not so bad because they can count it by 1,000 or 500. They don't have that, so it's not that bad. But not steady.
Like, what I meant to know, like for example, let's say the sum of, say X represent bus and Y represent cars. The sum of all the buses should not be greater than 50.
Oh, that's my X plus 5.
That's that.
No, when I just code 50, but that's my kid just code 50.
Like for example, X plus Y equal 50, isn't it? Less than what?
50. Well, my kid just draw X plus 5.
So now you're talking about rather than.
Because remember we were talking about the plotting graph, you know, how are they have a problem putting that on the graph?
Just my entire X and Y axis. And just say, when X has 0, Y equal to Y and 50.
But look here, they can't tell the gradient from they can't tell the gradient from the Y intercept.
Can't do that, it's about.
Or I just give them this for any line. One give it the X plus one, give it the Y, so I plot it.
That's what I do.
So all of this plot in when X is 0, you find you pull where X is put in 0, you find X, but when Y is 0, put in 0.
And then just draw one straight line come down. I do make them plot it. But that's, I mean, that's when X has 0, Y equal to.
And then you plot it. Yeah.
And then just use a rule and draw one straight line through them.
That's what I do too.
And if you want,
I saw my students having problems with numbers were being and could not put it on the graph.
But the number is big, it shouldn't be such a big problem because you can count it by 50, 25. You know, it shouldn't be, I don't understand.
And then no, let us say that part is there. X plus Y is less than 50. They're going to count up by 50. And then another inequality in the same question is a small number. Like X plus 5 is less than. X plus 5 equal 1. or something like that. They don't know where no it's one.
So remember that the y-axis and the x-axis can have two different scales. So even that one, but it's a matter of estimating. Now look at that's a skill you have to teach. So if you look at where 50 is, how much of the little thing you get to be 50? Divide that through. That's all you have to do. But I know these things are hard to say, and we don't understand why, because sometimes I'm trying to figure out why. Because even with this Mercedes, I can plot 1, 3, and I'm trying to figure out if I give them a quarter to plot to 2, all of a sudden everybody have headache, or 1, 6. So I understand, and I'm not seeing why it's a problem. So I don't know. We just have to expose them to some of these things. They forget the basic, because the basic fractional idea, the basic number sentence is missing here now. We have to manipulate. We have to count in 6 or in quarters or in thirds or in decimals. After ones, after 0.1, what comes next? Is it 0.01 or is it 0.2? These are the problems that they have learned. Those are the problems. And even if you have the 25, how do you get, so you divide this little section here if you want to find 1? So it's under simple division. Simple division. Any other thing? We're finished now?
Yeah.
Alright, so graphing, the scaling and the graphing can be a big issue. But you have to teach them how to count in decimal, counting fractions, and how to. I mean, I don't say how the big number should be a problem, but anyhow. Alright, so we're moving on to factorization. We're gonna look at the misconception. You're gonna write on the misconception, and you're gonna write on the you're gonna write on the method you use to correct those misconceptions.
Factorization.
It is the order of operations, multiplication. She can speak to that, right?
So please tomorrow remember your assignment will be sent.
I'm sorry.
Is that an assignment?
Yes, the assignment sheet will be sent to you this evening.
Okay.
And please remember to bring the things that you're supposed to bring for tomorrow's class. If you don't come with them, I won't be able to have a class.
This is the print off. So we need to see. So that's you. Do we each have to have an individual copy, Miss McCarthy, or can we just share it?
It would be nice to have your own if you must share 5, but it would be so nice to have your own.
That's good. Something. We don't have any creators.
You gotta remember, Bermuda is a small place. It's not like, you don't have your hills and,
We don't have good ones.
yeah, we don't have blue mountains and big trees.
I don't hear you.
We don't have big trees and mountains and all that. We don't have all that, a lot of people.
So when you save the papers, right?
Yeah.
All right, I hear you. Bring your laptop, bring your computer. They don't have many trees and stuff to make papers.
This could have the thing that, with that charge me.
Huh?
The guy like This a hard question right there. And that's been, yeah, this regularly given that, then.
You know what that is?
You're doing right?
Exactly, I don't think talking about this.
This
They
is
definitely gonna do that.
they're allowing calculus.
Schedule.
I don't know. She gave me that.
Sure.
I don't need that in front.
Okay, so what do you do? I got some of them today.
I don't think so.
No problem.
Right? So just make a CSC.
No, I've seen that.
Yes.
You got Kate. Oh, you see it. I already had to say it. It's her.
And then this is something else. So I'll take this one, specimen paper. And I'll take, see, I have paper, it's 2 parts of paper, they're 5 and 100.
Yeah, she's in.
Okay, guys, that's factorized, ha 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 ha.
Guys,
This
again.
got me handwriting. Oh, this is Kate. Idle time. Are we on lunch?
No,
Hello.
Yeah,
You guys having lunch or no?
not sure enough.
She just stepped out for a while. She's coming.
Oh!
No, don't say that.
I haven't eaten anything. I need some food.
Yes,
You guys
He said, "Could you something to me?"
I didn't know what you were. I thought you were writing something constructive.
I think you told me what to do before.
Kira, he read something. Look up and see.
I know.
No, you think highly of you do it.
I don't understand. I don't understand. This is a lot of stuff. I don't understand why some stuff is different. How come all of us printed something? Crystal, did you try to print anything?
I told you, I printed the exam report.
What you got now?
That one and then one around this here, because they're 2 different types.
Two different types.
And then you like printed the
The different
curriculum.
types meaning.
Yeah.
This is applied, and that's pure.
Pure.
So the pure one is here, this must be yours.
Right. And then this is
All
something.
right, do you know what you printed? So
I-
you don't need this.
Oh, my difference, yeah. I can't remember. Excuse me. I'm
All
not,
of this
I'm
we
at
need,
the, I'm at the
okay?
CXC syllabus here. I just got it printed. One each.
But this CSP.
Something, sorry.
That's cake. Right.
So this can be paid for a syllabus? That's it?
It might be. I don't know. It might not be that thick. But
So we agreed that we're going through lunchtime. Now let's go for lunch and come home.
Yeah, something like that.
John, were you tired of that?
Tired.
See?
9 o'clock.
I don't know what were you up to last night. I just see what last night. So we reached.
Hey, I'm supposed to see how I'm drinking out.
First
If he is, like, if it's
For some reason, that try to be going up. I want to drop my sleep before I come plan on go sleep.
you get a good amount.
Birds.
They're coming.
It's only late on Thursday. Oh, yeah, first watch.
Yeah.
I'm definitely get like 5:30.
Are you finished working?
Yeah.
Alright, come kids, they come to your job. What do you need us to sit down on the computer? What do you get paid to do? Huh? What do you get paid to do?
That's true, right? So my job. I'm working.
You can just put that right. It's
It's one of them. It's already. It's one of them. Oh, I'm gonna be traveling.
Alright, what are the problems?
What are the errors and possible misconceptions for factorization? Alright, Bermuda, so they don't want me to start at Bermuda, so I'm starting in Mono.
What? Really? Man already was done. Put it back. Three. You have three?
One of the things I hope is that I recommend students tend to expand individual terms instead of factoring, and some persons simplify the entire expression without
Because
instead of
an
factoring.
example, because all that's a lot of things that we can't
Alright,
understand.
take for example, you have like 2x squared plus 5x plus 2.
It's that down.
You foil that. You know, I don't
So
What's for
it's
try to follow in the last when you expand the, yeah. Or,
and then all of a sudden, it's
either way,
9.
you talk. Yeah.
So they simplify instead of factorize.
I simplify, that's
Like,
what
yeah.
oh my God.
So the goal is different between factorizing and simplifying.
Yes, yes.
but I remember before you had the 2 exams, and then the 7 exams.
It no matter how them come back, let them stay. Simplify.
And we can't
And
understand
next thing I see them do is expand the individual terms and then them do some weird magic with that. But like, right, for that now, what they would have is like 2 times x plus 5 times x plus 2 times 1.
I've never seen that one. I see the most simplifying one, but I've never seen that one.
I need to carry some of the test papers from school and show you. As a matter of fact, Thursday I'm going to carry some of the test description. Because some things that they don't have paper. Magic, black magic, they will come with.
I'm not even read that one, okay? That it's the same question, it's the same thing represented another way. And that's it, that's that. Get what I'm saying?
But like with this now, what they would do, they would factor the x in it. So what they would do, they would factor the x from 2x and 5, they have 2x plus 5. Yeah,
Oh,
they have
yeah.
2x
I've
plus
seen
5
that one, so
plus
it's
the- plus the
You
2,
can't
or
see.
sometimes they don't even.
can't see it.
Can't see.
No, can you
Oh,
make
sorry.
that
Why
okay?
you can't see the, we see the.
Well, no, where you're right is that you just need to see where you're, what you're
Right
right.
here.
Yeah. Thank you. Right there.
Yeah, and then after they do that now, it's either the 2 disappear or the 5 turn to a 7.
minutes now. When somebody did that, I stopped this stuff.
I see they do this all the time. They stop there. They usually stop there. I see
No
this
man,
all
my
the time.
opinion, I always tell my children, you know, there is always an answer to get. So they always give me an answer. My own them always is either the 2 disappear or the 5 or 7.
Oh, yeah, so
Yeah.
Alright, so write that example. I don't know what to call that, but write that example. I've seen this one too many times. This one. This is a very
So
common
what
one.
can we say? What?
How do we describe this? Just write the
Alright,
example.
they don't know because they're doing what do you call it? Factorizing by applying each step.
Yes.
So they don't know the
Factorizing
different
quadratic.
time.
Yeah. Yes, the different time.
Give an example.
It's at the different time. So it's a different shade.
You can't. Outside.
That's the
That's
problem.
something.
The problem is,
Just make it simple when you put everything outside.
no.
There are problems?
the pro-
I don't think about one where you have something like
Two X.
negative xy plus y. So you factorize out negative y, but
It should be that.
instead of negative, like
I don't
negative
change all the
one,
steady
yeah.
numbers inside the bracket.
No, like the inheritance would be negative, like negative xy plus y. That's like negative xy plus y. And you have equal negative y outside, one bracket x, and you have plus y.
Yes, that's an integer.
Plus one, plus one.
That's, yeah.
That's integer, that's an integer.
Yeah,
problem.
so integer.
General problem.
Yes, and that comes into the quadratic as well.
Yeah, that's a general, that's an integer, so because truthfully you can put integers for everything.
Everything.
They just have a problem managing integers. So I wouldn't bother write integers as that you need to. But
Well,
integer,
next one, I think was like an integer, so like something like you want to see a factorization and some come like 2x plus minus plus 2. You have some students, they give them straight positive numbers.
negative right.
Anyway, but once they put in something like x squared minus 2x minus 3 or like that way, product and some minus 2, that just start
And
confusing.
that's an integer problem, you know.
So yeah,
It's not a fact because they understand how to factorize.
if you give them straight positive, no matter all of the time, they give them anything positive, get it correct. Once
So they can factorize now. The idea is the objective is to be able to factorize a quadratic or whatever expression. So they can factorize, it's just that they have a problem with integers.
so some of them are
Yeah, it's an integer problem.
adding a sub and
But, but here's the next thing. They don't realize that factorizing is another way of writing the same expression.
Mhm.
Because I was reading one of the CFC report, and they were saying that students don't know that they could actually test back to this.
They must know that.
No, but the thing is, as I recognize that when they're teaching fractions and factorization, especially in 10th grade, they don't really bring out the concept to the student that it's really just you're finding a number that can be divisible into another number. So like, you don't start from basics, like, you know, you have 6, what are the factors of 6, and if you multiply these two factors, you should get back whatever the case is. So from that time, they would have learned that there are tests there that you could use.
And that's the reason why when you're doing factorization, even though this is a method to correct the problem, you have to do trial, guess and check.
Yeah.
So it's an important thing. So even with this now, I don't know if this is able to be factorized.
Yeah.
You just have them doing that and guess and check. So alright, the factor here is 1, 2. What are the factors of 2? 2 times 1 or whatever, and there's another 2 at the end, and then try to put in the different factors into this and multiply them to get back that. So it's a good way to start guess and check. Guess and check is a good method to use. So it might be time consuming, but they're getting to know that if they clear by the bracket, they get out the original thing. It's time consuming, but it's a method that you need to introduce.
I don't know if I agree.
Well, I believe,
Yes.
I believe in that 110%.
In the event, just try it out. So what
Alright, Adrian, you're next.
Okay. I had a problem where you have the HCF and the LCM students always seem to get them mixed up when factorizing.
is lowest common denominator.
Highest common factors. What else? Anything else?
In terms of the proof, when students factorize, especially when you're supposed to get 2 binomial expressions,
Yeah.
because they get the same answers in the bracket, they think that it is correct. And
That's
they
true.
don't know how to prove that.
Whether they're correct or not.
Right.
See, we're just talking about that. Okay. Alright, Bermuda. You get lost now, Bermuda. Can't come time, right?
You want to talk about answers, you can complain.
Let me see, I can't see the rest of what, go over just a little bit, simplify, differentiate, I can't see what else you got.
And highest common multiple. Can I see the word,
A
please?
common error, I would say, is probably most likely multiplication. In factorization, is definitely a common error, like the.
Because I think if you're trying to say not multiplication but factors, looks like for factors.
Alright.
That's the thing. They don't know to find factors.
But factorizing variables, not necessarily.
Alright, how do we correct these errors now?
Oh, there was one. There's some factorization that you need, you do two types, you know, one. You do two types, you know, one.
Oh, so like if you have,
And they don't know if you
so if you have, for example,
I don't know if them that's like, maybe X the code minus. Or,
and the 4x squared minus 4. So they would factor out the 4, and then end up with x squared minus 1. And then it's different between, so they end up with that, x, so end up with 4, that, x plus 1, x minus 1. That's what we're talking about. So, in other words, factorize.
Oh.
Because we'll be using this.
So how will you?
And she said they had data. That he needs to get it. So he needed it yesterday. I don't know.
Alright, the first problem, simplified.
We need to move on. That's why I said to
I think that when students hear the word factorization, what's the root word there? Factoring. Factors. So there was the factorization as factoring. So even sometimes we just write something on the word factorization and to them, and we just show them the algorithm, but they don't understand really what they're doing. So factorization, they need to start thinking factors. So if they get that, they should not be simplifying. You agree with me?
Yes.
Yeah.
Yes.
Yes. So even the meaning, the idea, when we got factorizing, the idea behind that is factoring. So they need to get the concept. The concept there is important. Factoring concept.
I don't know. What I normally try to do is I try to use try to start multiplying using a distributive. So I have something like 3, and on the inside of the bracket I have something like 4 plus 8 or something of the sort. And then what after the find with multiplying with the brackets, then I show them that they can form back the brackets, get back from where they came on. Basically, then I explain that what you've just done is factorizing or factorization.
So
and then we kind of try to do
that's why you need to use the word like, let's look for common. So you know that the factorization is really factoring. This is the language that you need to use with it. Factorization is really factoring. We're looking for factors. So if, for example, so remember you have to do expand, you do that simplifying first. So for example, if you have 5a plus 10, I'm looking for what is called a common factor. What is so we have to use the right terms. So when they say factorization to be factoring, it should not be simplifying. So even sometimes we just start with factorization, we just start the maths. And then we didn't stop to really truly explain that there should be factoring. There should be searching for factors. Agree with me or not?
I agree.
Yeah. So we talk about common factors here. What is common between this and this?
5.
Then when we get to another thing, let's say x squared, 5x squared plus 10x. We're looking for, this is highest common factor. Common factor. So common factor, what is common there is y. So you build on that. Searching for common factor, then highest common factor till you reach to the quadratic expression. So when we reach the quadratic expression, it's the same idea. We're factoring. So if I have 6x squared plus 19x plus, I don't know if this must be able, this can be fact. No.
Change it 9.
Let me see if I have a fact.
Go change it 9.
Alright, so I was saying that one thing that we could use is guess and check. So we think about factors. What are some of the factors of 6? Factors of 6 is 3 times 2, 6 times 1. What are the factors of 15 here? 15 times 1, 3 times 5. And then you know that you should have 2 brackets. And you start to put in these. I can try a 3x plus a 3. And so we try to put in these values until we guess the right thing. How do we know we get it right? We multiply these brackets to come back here. So that's how we can do the trial and error. We can do a trial and error. I think that trial and error is a method that is time consuming, and I think it's the last method. But it's the idea to get them to start seeing that all I'm searching for is this is one factor and another factor. But like 2 binomials to get back the original thing. And that's an important thing that we need to do. But I agree on that, but that's what I think.
No, yes, that method. I don't have any problem with the method.
Sure.
I'm just saying that you should, like, after the first certain stages that I don't know, they can with mental.
Yes, but even with just positive numbers alone, it's not a method of looking at them because eventually you're going to show them the other method. But it's the idea that it's 2 binomials, that's what you want them to get. It's 2 things I'm going to multiply to get back this. So even if I don't know the answer, even if I can't remember the steps, like the steps that we normally teach, if I don't remember the steps, I can start thinking, so other students can use this method, something will use this method enough. You don't agree with me, Jack McDonald?
Oh no, that's the method I learned. I didn't learn any other method but trial and error. So I agree with the trial and error method.
It's a good method. I want to teach that.
It's just that with everything, I probably, alright, because what I would do, I would use trial and error with only the smaller set of numbers. I would only use it with the smaller set of numbers. But that's why I learned factorization, by trial and error.
And that's my idea. When I said trial and error, Bermuda, are you hearing me or am I not including you?
Well, it's
Then you
We're
get
talking
excited,
about
you so very fast.
We're talking about factoring. Are we thinking about, we're saying when we talk about factorization, we don't walk in the class and just start to do, we're just write a big topic and start to do steps. We need to give students the idea that factorization means that we're looking for factoring, we're looking for factors. So we start
Can you go back to how you do your trial and error? I was a little bit easier. I didn't really
Alright.
understand exactly how you were doing it. Basically, you said you looked at the factors of 6, 19, and 15. Was that what you're looking at?
No, 6 and 15.
6
And then we
and
try to put in the
15, okay.
different factors, different ways, and then we'll multiply it back to see. It can be very time consuming though. Then multiply it to see if we come back to the original thing. So I'm saying that for me, I wouldn't teach that as an exam strategy. If you know what I mean, I don't think it's ideal because it can be very time consuming. Or what,
I was saying it depends because if the student get enough practice by the time the brain just clicking.
Yeah.
Yeah.
So it can be time consuming.
Yeah.
But it's the idea that is 2 things, these 2 things, and it's a multiply to get that thing. So when they do something different, they know that it can't be because I'm searching for factors. The whole I've been searching for factors. So when we talk about factorization, that idea of factoring or searching for factors should come alive to them. So they're not simplifying or doing anything else. Yes, Adrian, you were saying something? You want to add something?
No, miss.
Are you agreeing with me so far?
Yeah, yes, I agree.
What are you agreeing with, Adrian?
That the trial and error, some students will prefer this, but it's time consuming.
Yes.
And they will actually prefer this over using the formula itself, even when it's presented on the paper. Students just don't tend to use the formula itself. I think it's because of the substitution.
Formula? No, we're not talking about using the formula. We're talking about
Yeah, I know
factorizing.
that. I know you're talking about factorizing, for example, the quadratic expression.
Yeah.
But students, they tend to prefer the trial and error over the other methods. But again, it's time consuming.
And I think, Adrian, I think that trial and error is a valid mathematics strategy to use to solve problems. I tell my students all the time, guess the answer and check it. Try something, try to get the right thing. You can guess and check. Trial and error is a good math, it's a practical problem solving tool.
I don't mean to be,
Miss,
but
I tend to discourage, I used to discourage it because in terms of the presentation, it leads to very untidy work.
Yes, but you need to show them how to start writing down math language or writing down what they think. So, alright, so for example, if they're trying two numbers, say, okay, I'm using guess and check or trying to error what they want to use. Okay, so I'm going to guess 6 and 4 to be my answer. Let's give it a general thing. I'm going to guess 6 and 4, alright? 6 and 4 doesn't work because the answer is too big or whatever. So you teach them how to write down statements, little statements.
Right.
You were saying something.
yes. Because I was saying that if their answer is incorrect, kind of answer, they don't have a chance of getting any other marks. But if they were doing the other method, let's say that this is worth 3 marks, and they got factors for 6 and 15, when you multiply 6 and 15, and you get that middle number and all of that. Yes, I got that part, but the last part now, when you are factoring each group, there was some integer problems, so to speak. The math, they could have gotten
2 out of 3.
Okay.
Sometimes it's 2 out of 3 because one integer is 1 mark, so you don't punish it 2 times.
Right.
So if it was an integer error, it's just 1 mark, so because the answer is going to be followed through. But if I missed it in the middle of the top, you're going to work from there to get the answer that says 1 mark. I see what you're saying and I understand, but remember that we're also looking at methodology. What can give them a greater understanding? So, because that method we use now, we just multiply the A and the C and think of and give them right on the factors and that give us the B. It's not necessarily open to understanding what is truly happening because that's a procedure. I agree with me.
Yeah, yeah.
So, but when I give them the trial and error method or the guess and check method, you're giving them the idea of factoring the budget. It's 2 binomials that are multiplied to give you the top answer. That's the idea. Agree with me or not?
I agree.
So I'm saying guess and check can be used, but I would also go ahead and show them the other algorithm, the other method. But this is the first thing I would try. And guess what? Some students will always remember this. I can't remember which one to multiply. Is the B or the C? And which term you need to get. So students, that's a challenge, but it is too mechanical. They don't remember.
But you have not a procedure with the other method because they know the group method. They know the group method. The factorize this group, factorize that group.
It's the same. I think but the major problem time I see students make case here, and tell me if I'm wrong, is that they can't figure out, sometimes they don't remember, Is it the A and the C that have multiplied, or the A and the B and watch like is the make the letter? That's a big problem with them.
Yes.
Yeah.
But anyway.
So I'm not kicking that method enough. Don't get me wrong, but I think that they need to be exposed to this. This is important. That's what I think.
And before we move on to the next thing, I usually tell, because some persons are having problems knowing the difference between simplifying and factorizing. I don't know if this is wrong to tell them, but I normally say that simplifying is actually like getting rid of the brackets. Simplifying is adding, multiplying, dividing.
Operations.
While factoring, at the end of your answer, you should have brackets. Is that a wrong thing to do?
No, because truthfully, you're removing and inserting brackets. That's an idea. But it's a lot more than inserting and taking out brackets and inserting brackets. It's a lot more than that. So, but even though we can tell them that, but we'll tell them more.
Yeah.
Yeah.
Because they know how to simplify, they know how to factorize, but it's just like when the question is given to them, they are wondering which one of these I should.
But when it's about simplifying, that's why you need to teach them the equation different from the expression. So you solve an equation, but you simplify an expression. Why do you simplify? When you're solving, the answer going to get equal, and you get a value for the unknown. So it's because sometimes we don't differentiate between these little things, the things that cause a problem. So we have to teach what are equations and why they're equations. What are expressions and why they're equations. Why do we solve here but we simplify here? So these things is a part of the math language we have to use in class, and we have to ensure that students get it and get it right. Agree with me? All right, Bermuda, anything you want to add?
No.
Sure.
Yeah.
Not to factor, simplify.
Tell me what you understand from what I've been saying.
You have to separate the equation from the expressions.
Yes.
You should use trial and error because it helps them to. And you have to know the root word of factorization is factors, so we must think in terms of generating a factor. That's why we can use things like trial and error.
All right, well said, very good. I'm impressed. All right, the next thing we're looking at is trigonometry. So you're supposed to write the likely errors, now you're going to write the method. What methodology? Well, can we get a speech, right? But I hope you guys are learning something.
No, listen, it's just that I think factorization is one of the main problems in CXC.
It's a lot of problems, and that's why they have to understand even the difference between two squares. I don't want to disrupt everybody. Look here. So they should be able to look at that and write on the answer. Exactly.
No, but look here. When you teach difference of two squares, they sit down and work the problems the same day. You see the next day go back to class, so they're talking about the same thing you did yesterday. Serious, that's how they are. You teach it to them and they sit and they do the work.
But look here.
And you think them
Even
understand.
teaching factoring. You see the difference between two squares? Guess two numbers, like we start talking about square numbers. Guess the two things that you can multiply and give you about that. That's what I'm. Just have them, alright, what's the factoring? And you start to some raise to some power, some start putting brackets. And you're going to put some brackets. Start thinking of that. What you're going to. So you need to start. When they see this, how do they think? When they say factoring, how do you think? Is it kind of thinking that they want? I know it's challenging on there, I tell you, I swear. I know.
Factorization part.
It's a problem, it's a problem. I'm not teaching me. Me too, I know.
We're still so long teaching factorization.
You have to teach them, you have to give them that idea. Spend time to develop the factoring idea. You can start by just factoring regular numbers.
Number start like with 6 or 8 or 12.
Yes. Some teachers walk into class, they're teaching factorization. Today's topic is factorization. This is what you're doing, this is what you do. So they don't have an idea. So that's why they mix up sometimes What is simplifying out because it's they just see that topic, it's just a topic, but the topic has a meaning. It's an idea.
For the time they need to recognize that spirit is above the X, right? I don't think they understand what the spirit above the X means. I mean, the two above the X means. I don't think they understand that. Because it doesn't spirit on word. And any other, it's here for a reason.
I think that's a tough. If you decide we're gonna teach math, it's a kind of challenge.
No, I think that the students being proper mind find teaching maths, especially at 10th grade come up, is the person who can what call it from, because they don't really teach the concepts. They just come and then try giving them the content and then teach some misconcepts for you but try correct, and it's just difficult. So I'm spending so much time reteaching and teaching stuff that I should have learned from 8th, 9th grade before I can go to my lesson. So that killed me.
That's one of the reasons why my courses are not. I don't like to read whatever. You can read a notebook. This is the thing. So some lecturers come and they give you a lot of readings to class and read. I don't believe that. You can't read a notebook. But what we need to get right is the methodology. What do the instruction? What to tell the students? That's what we need to get right. You cannot read it in a spare time. I can tell you. You can't read in a spare time about. Don't tell me what to read. Like that's just an idea. But I can read in a spare time.
But it's true that it's a quiz so we can learn how to teach. Teach the children.
What also the important thing to be to tell them what is it? Because a lot of things that we talk about, a lot of children they don't know these basic things. The basic things that we talk about here, they don't know them. I walk into a class and teacher teaching bomb gas. And in the left and right sweep, we don't really, and I'm not saying it's a teacher's fault too. No. It's all we were trained. That's what I'm doing. Looking at teacher training. What is wrong?
I find it quite surprising that, I mean, this might be straight from the point, but you have teachers who don't know what to factorize. When you start to factorize, they call on another teacher to come and teach it. Teachers who don't know what to teach their sons on top of these things. And then they expect the children to.
We have to know it and not only know the algorithm, because you guys did it, but the algorithm different. But understand the idea that surrounds it. What's the idea? When you think of this topic, what idea should come to mind? So let's hear the topic, what idea should come to mind? So for example, if I take trigonometry, what idea should come to mind when it comes to trigonometry? Triangles, the measure of triangles, angles and angles. It's the measuring out. That's it. So if they say they can't, if they say they think trigonometry, they shouldn't be thinking of quadrilateral or whatever. They should know that I'm talking about triangles. We're going to talk about triangles. It's true. Instead of a big word in isolation, we're just going to talk about triangles. Are you ready?
Yeah.
Yes.
Alright, Asia, you started first this time. Come kids and get up.
Okay. For trigonometry, I have a lot, you know, miss. I'll give you two, right?
Alright.
One of the problems that I have here when it comes to students is bearings.
What about bearings?
One of the, say for example, you can have the vocabulary falling under this are the language where you will ask a student, what is the bearings of P from Q as opposed to the bearings of Q from P? Yeah, they don't understand how to measure that.
And that again is interpretation. And it's how do you teach them to interpret it? I don't know. I don't know how to tackle that interpretation problem. So I don't know. I really don't. I understand the problem because I'm having the same problem. It's something I'm thinking about. How do I get students to interpret math questions properly? Because if I'm there with them, I'll guide them. Like, well, look at this. What is the question? Read it again. Da, 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 da. But when I'm not there, they interpret it all wrong again. How do so I'm having that challenge too. So I said that I need to look at how do I. So when I figure it out, I call you guys up and tell you.
First we figure it out.
Yes. If you guys figure it out, you call me and tell me.
First then figure it out and tell you.
Next.
Oh, I also had a problem with sketching the diagrams. Students find it difficult to sketch diagrams in relation to trigonometry.
And you know what is the problem again, Adrian? It's the same language thing. They can't read the thing and then draw the diagram properly. So it's the same language. So that language thing is a problem. You don't agree with me, Adrian?
Yes.
So that reading, they need reading. They need to go back to they need a reading class to read, not only read by calling words, but learn to read and interpret, make sense of what they're reading, and that's a problem.
I think another problem with the trigonometry is the students being able to identify the different type of triangles, to know what operation they would use to work out whichever question. Because sometimes
like type of triangle, like non-right angle and right angle.
yeah, basically. Because a lot of
So
the
you're trying to
times
tell the grade levels can identify right angle and non-right angle triangles.
they use Pythagoras theorem on everything. For Pythagoras theorem, then they use on everything from an item and an EDMC. And sometimes they pick 90 degree on the sign and then just do something completely different. I don't know. So I guess it's identifying the angles and triangles.
I don't know if any of you guys saw this year's CXE math paper, but there was a particular question on angle of elevation. Now I taught that topic. I did elevation as well as depression. I spent a lot of hours teaching this topic and gave a lot of questions. Students seem to understood, but on the exam, they did ask what was the angle of elevation, but it was actually on the diagram itself. When I spoke to most of my students, I saw about 20 of them, and when I was getting the feedback, none of them got it right. So what could have caused that? I mean, what
I don't know.
Problem is?
So I'm trying to figure out how do you teach them? Do you teach them that angle of elevation is like they're somewhere looking up, and you talk about the line of sight and the horizontal? I don't know how you teach it because
I did teach all that, miss, and I did give them diagram. It's just that most of them told me that they thought that they had to work something out.
So they
You see,
couldn't
the
have
answer was
diagram.
actually written on the paper.
So they could
It
not
was
look at
there on the
diagram.
diagram.
So even when they should know that the angle of elevation is formed between the horizontal there and the line of sight. So even these concepts. So I don't know how you teach it or what you tell them. Because, but I don't know.
Some of them said that they actually thought that was the answer, but they didn't think it could be that simple, so they worked something out.
That's double thinking.
That was You know, Adrian, I understand what you're saying because, Adrian, I have some students, whenever I give them a problem and they get a decimal or a fraction for the answer, the question not right. Miss the question not right because you get a decimal answer or a fraction. So it's the kind of thing, you know, probably need to move from their minds because it's the kind we need to remove that thinking. Once I get a decimal or a fraction, miss, I get a decimal saying it's not right.
They're not.
I don't know. So is that's a thinking I need to pull away, get them away from. If it's too simple, it can't be right. Or if it's a decimal or fraction, it can't be right. So.
No, but really and truly, if you tell them and you demonstrate, where I am standing here, this is my eye, I'm looking up. Where would be the horizontal line? Where would the angle of elevation?
I line, you talk about the line.
I do it, I show them the action, and this is the horizontal.
I draw it from your, can you draw it to sit here, I'm here, and this is my eye level. And that's here, I'm looking there. So you can even draw it from you doing the, I don't know.
If you draw the diagram, you know, right? If you draw the diagram and you just include the angle, right? Just the angle, and you say, what is the angle of elevation? They can tell you 20 degrees or something like that, right? But if you give them the angle and you put on the measurement for two sides, right? Even when the answer is already there, they're going to start calculating all sorts of things.
because their culture, they're not thinkers. That's the thing, you know, they're not thinkers. They must do something with some numbers to get a solution. I think that's how they think. I need to do something with some, once I answer math question, I need to do something with some numbers to get the answer. So they're not thinking mathematically, they just think, I just need to do something with some numbers, I don't care what. So it's procedure. It's all about procedure. As I said, Jomo. I need to figure out what to do with two numbers or a couple numbers to get some answers. That's not the thing. Yes, the most of our working. And then we emphasize to show working. So they feel like everything now must be a working. So sometimes we tell them little things and then we how they interpret that.
Tell them to look at the marks. That's right. Let's see that look at the marks. Never know what they must do.
I think for bearings, before I go into any calculation, I draw, I sketch it. I say, when you're doing bearings or whatever, draw. Or angle of elevation, do a sketch to know what to do. It's on the exam paper. They draw some things, like for example, they say the bearings from the person traveling from Jamaica to Cuba and whatever. You know what was on the paper? A map of Jamaica with a flag flowing high. A map of Cuba with a flag.
Because really, like students, I think we don't really teach them to visualize things properly.
Spatial awareness.
Actually, you know,
Spatial awareness.
I don't think we teach them to visualize things properly. I really don't.
But that spatial awareness I'm talking about, it should be done from building block stage, you know. So that's the thing, you know, you see the bottom is not laid properly. So that special awareness comes from the building block stage. It comes from identifying your left different from your right. So these are the little things, east and west and different from north and south and a map. So these are little spatial skills that they don't have. What can we do? We have to go back down there and give it to them. We have to go back down there and enforce those skills. Because the key special skill is in the early childhood by allowing them to go through the chair to see if they can go under, up. They eventually start introducing to left and right, up and down. So these are special things, building blocks. Can this fit here? Blah, blah, blah. I don't know. We need specialists down there because we still don't have a public. We're going to get specialists down there. That's a product.
That's one of the things, like, at school, they have like maths teachers different from English teacher. I think in primary school, it probably needs to be the same because I'm not saying that you can't have somebody teaching all areas, but
Most
it
of
would
them.
be better if you have somebody who's just proficient in one area and they just work. So for one grade, you just have one math teacher and English
I think they're
teacher.
trying to know.
Yeah.
They're trying it now.
Especially for maths. Like when it's maths time, they go to that place. But like the other children.
Okay.
Because of the nature of math, and you guys doing the nature of math. Because of the nature of math, we do need specialists. Math is not like other subjects. We do it. It's a spiral curriculum. We need prerequisites and stuff to build on. If those things are not in place,
I do such an
That's
education.
exactly what we're, that's enough.
so because of the nature of math, we really do need specialists in the primary school. I believe that 100%. Because the teachers that we train to teach in the primary school, they don't like math. So they don't care about math. So that's another problem. You can't have people who are mind molders of those young children in the subject.
So only when I was in 6th grade, I remember doing any decent math in primary school.
Yeah.
Only when we in the 6th grade.
And way to learn is very mechanical, it's very just this the lines up like this and do it their way here. And it's never thinking, not about thinking, never about
You
thinking.
never teach her to think and that. You just do. This is what I said you were supposed to do. Why you do this?
Yeah.
This.
And even if you do it another method, you have to rub it out a bit.
Yeah,
The teacher
exactly.
say you should
Not
do
even
it.
if you get the thing right,
Yeah.
like, you get it.
Alright, Casey,
Anybody else? Bermuda?
come with the finish. We have 10 minutes
Yeah,
to go.
I would grade, basic algebra.
Basic algebra?
Yeah, basic algebra.
Basically, trigonometry is
No.
understanding angles.
They don't understand basic algebra. This is what was on your paper, on your quiz.
Alright, so that algebra you're talking about is being able to manipulate, knowing
Yes.
it's a more changing the subject of the form and all manipulating the equation. That's what you're talking.
Yes.
Yeah, transposition.
Transposition, yes.
Addition, yes, that's the word.
Can you focus on the board we can?
Can we focus on the board, please?
We
Can you
took
focus
one
on the
from
board?
closer. We see you
Closer to the board.
Zoom in. Zoom. Right. Yeah, thank you, Kezia. Thank you, Kezia. Right there. Zoom in. Zoom in.
Some more.
There you go.
Thank you very much.
Because we're going to do here, so say hang on.
On one of the reports, on what, I think it was the CSC report, they were saying that students have difficulty between using the trigonometric ratios and when to use the trigonometric formulas.
Yeah. So that's a difficulty. So for example, when they're using the trig ratio, they don't know if they should do sine, cosine, and but I believe there's a big problem. You know what is one of the problems for that? They don't know when to use tan, cosine, and sine. Because the teacher walks in the classroom and the teacher does this. Today, we're doing trig ratio, we're looking at sine, and for the whole class is only sine alone to look at. And the next day, they look at tan alone, or cosine. No, the three things should be done together. You identify different sides, you put up your sticker or you carry a piece of wood and you make a triangle, lean it up against the wall and you make a right angle triangle. You do your measurements, identify your parts, whatever, and you move on to. Alright, so if you have this and this is what is missing. So what do you have and what is missing? That's what tells you which trig ratio to use.
Yeah.
What do you have and what is missing?
When you look like you're talking to the converted.
Huh?
You know, I was saying you're talking to the converted.
What do you mean?
I mean, as in, like, us here, those are things that we try. But you're going to find that on the whole majority of teachers, they don't really do that.
Yeah, but I know.
And that's the sad part about it.
I know that's why I have to express. I am telling you these things, and when you go there, you
And try to inform everybody
effect
else.
some change because that's how it should be done. What do you have and what is missing? So you record these things, and then from that, to see what you need which should ratio to use. But I see teacher walking, and today they do the sign alone.
Your side.
And to the next day it's sugar alone, it's true. And the next day it's cosine alone. So up to this, let's finish teaching sine, cosine, and tangent. The student still doesn't understand. When do I use a sine? When do I use a cosine? And when do I use a tan? The tan? And I lie. It's true. So we have to take some responsibility too.
And they don't know which one is the opposite side, which one is the adjacent.
But
No, they
but
do
adjacent,
have problems.
adjacent is two sides because then adjacent actually means the side.
Yeah, that's what they're trying to tell them, or they don't. They have problem with that. They might know that sine is opposite over hypotenuse, and they write it out, and they could be that. But to put in the correct numbers where
I know they have because some of the teachers they teach it like they draw the same triangle all the time. Is that
yes, and draw it one way.
one way?
Yeah,
Right angle. They draw the same triangle all the time,
This one.
and they use this one all the time, and all the time the angle operates. So every time this side is the opposite, and the student just believes so the side at the bottom is always the opposite, and they never did this. And they never. They never did that. It's true. It's true. It's serious out there.
I just have one more point to children and we can move on. I realize that persons don't know the difference between angles and a line. For example, they say, calculate the length of AB. At the end of the answer, it's in degrees.
Yes, it's degrees. So we have to figure it right. So
Yes.
when the students think of trigonometry, this is the thing. The student needs to be thinking of triangles. Trigonometry is associated. So the idea is about triangles. So what do we do with these triangles? We're measuring sides and angles. That's what trigonometry is. Trigonometry is about triangles. We are measuring sides and angles of triangles. So that's the idea. So when they get a trigonometry, they know that it's a triangle they're working with. They're working with triangles and they're measuring sides and angles. And we need to be able to differentiate. What is the side of a triangle? Because they take this for granted. And where are the angles? Identify the angles for me. And why is that angle? And why is that side? So they need, alright? So what do you measure the angles with? You measure the angles in what? Degrees. And the sides there, what is the distance? So it must be in linear measurement. So these things,
They don't know how to use a protractor.
what is a skill that you can quickly teach them if you have the time? What is that? But trigonometry, triangles, and what we're doing with triangles, we're measuring angles and sides. That is important for them to get. What's the difference between angles and why is the angle, why is the side? How are angles measured? What's unit and how are distance measured because the sides are distant. That's important. Alright, we have 2 more things to go. Because it's almost time to go. Because we didn't get to go for lunch, so we went through lunch then. So we have simultaneous equations and alright, so I'm gonna do simultaneous equation. Tomorrow we go about functional relation. I don't want to rush functional relation. Functional relation, I'm not gonna rush that one.
I just don't have to do
But and the next level is discuss how we teach that inverse function. So we have it's the opposite of what we do. Because it's so mechanical how they do it.
The CXC question this year actually caused me to realize what we were doing with the but we're just know
Exchange
why
wise
don't they,
and
that's how I knew it. But when they gave us a question, they said x is 4 is added to x, then a number was 5 was subtracted and we got a number. find the opposite way now to get back and say, you just,
Is
I
it
know
opposite
which
or
step to look
No, but
first
you
and all
can
that.
have someone who can just look like, they just give them, like, there's a simple linear one, them, like, X plus 4 by 7. You can just study the straight up, so one time from like the sport and work. And I was kind of so
Sometimes
funny.
X plus 4.
Yeah, them just right, you know, like, sometimes like if you have whatever the person say, multiply it, subtract that. So they might even work out.
So you do the opposite. You do
But
it's the
the
opposite.
reason I make sure them that is like if you have the composite one, like the hard type.
And
Like
the fact like 2x plus 4 over.
over an X, that's how we
One.
that's how we get it. That time you know is when you say why.
Yeah, but you can't do that. But the need to get that is the opposite operation. The opposite operation. That's important. It's very important. We're gonna look at. All right, quickly. Let's look at simultaneous equation. What you should by now put in the likely errors and possible misconceptions.
The first problem with that is that most of the times I don't really know how to transpose.
Plus
Transpose.
Like especially when you're doing substitution and you're supposed to get like X, like X is subject and formula or Y is subject and formula, and they normally have to put it in.
So what we teach them substitution method.
Yes, please. I teach them alternate methods, I teach them graphical substitution.
So you see, sometimes we try to put even simultaneous equation on them, and if they can't make something the subject, if they can't transpose, then they can't do substitution. They're gonna have problem. So most times the challenge is coming from the foundation. Coming from the foundation enough, because making something the subject should be done probably grade 7 or 8 or the simple ones done in the lower school, right? So they get the grade 9 and grade. Yeah, you do the more challenging one, but these things should be done. And they don't know where to add and subtract because we shouldn't teach them add and subtract. We shouldn't be teaching them that just to add and subtract. I just teach one thing. Subtraction all the time.
And you can,
Subtraction all the time.
But the thing about the subtraction, they have to see that the subtraction negative from a negative. So that's a problem with it. Anyway, we don't have to be going on that. I'll go pick up I need to do. It's true. What happened?
No, nothing. Besides laughing at I can't get that yet. I'm fine.
No, and I'm so starving. I don't need to go somewhere, so I should go to in the lunch. Shop on. Oh, they give us free lunch, so if they're eating, can still go to the lunch.
Really?
Awesome.
I didn't know that. That you don't need to.
Alright. I don't need to see Miss Keys before. So, alright, so guys, everybody. Alright, so you're tired now.
I can tell you that any lunch.
I haven't had any food.
All the day today. But you can.
Alright, so what I did, we went through lunchtime, right?
Yes, I do.
So we didn't get any lunch, so you get to go home. You get to take your lunch. No. You don't need to come back.
You say you're gonna send us something, right?
Okay, so
Because we have
Yes,
assignments or
assignments with
something?
this. Yeah. I'll email it to you later.
This McCarthy,
Yes, sir.
give you a heads up,
Okay, shh. I didn't hear that. Please say again.
The college is closed next week apparently, and we were not aware of that. So, we are putting in a request ahead for those, with Dr. Hart may contacted, the office. We need to guys a heads up that we are not going to be able to do this, the, class in session next week.
All right. So remember that we are recording the sessions, so you guys can look at the
Yeah,
recording.
exactly. So, but the question is if we can maybe make that request that those two recordings at least be
Available early.
early received to us before, we come to class on the Tuesday, the following week?
All right, I can pass on the message, but it's not in my control so much so, but I'll pass
I
on the
agree.
message.
But I just
All
want
right.
to let you a heads up.
Are we able to, Mr. McCarthy, are we able to sign on at our computer?
If you're able to do,
Sign on at our home computer.
ORV,
I haven't on a computer.
I didn't hear that.
That we don't want to miss a week worth of class.
Yeah, we don't want to mix the leads around.
So we're trying to figure out how can we still be in class.
If I have to break any building, I'll do it.
Okay, all right. You know what? I don't know what to tell you. I really don't know what to tell you.
The whole campus will be.
The entire campus will be closed.
The whole campus is going
The
to
entire
close
campus.
because there's a holiday.
I don't know, but I'll tell Miss Moore, I'll tell the coordinator for our program here, but I don't know what else to do, okay?
Okay.
But I'll tell Miss Moore.
Good morning, thank you.
Thank you very much.
All right, have a good one.
You too. We'll see you, Dorothy.
Okay.
Okay, I'll see you on Thursday.
This is really good.
This is
Also, we just go ahead and say, this is not like we're, we just go ahead and say.
It's all together, come, let's go. No, I don't think that's good. Hi, ladies. Twenty, right? What?
What's the type of person you need? NGNT, right? Oh no, I want to do something over by
BBTK.
organizational behavior. What who has the remote?
I don't
And the thing. And say no, we'll be good.
Thank you.